Morning to all of you. Okay. Vanakkam, vanakkam. So I hope some situations are going on all over the India. I hope everybody knows what has happened in Kerala. So some faltu fellows has kept some crackers in a pineapple, and they offered the pineapple to a pregnant elephant. Due to that, she died by standing in a river, and she was pregnant. How vulnerable it is to do such type of things. I mean, just imagine if we think like that. So nowadays, the wild animals become less wild and humans become less human. So it was devastating. I have seen that news yesterday, and I was looking over there, and I don't know what they have done with those guys. And one side, yesterday, corona case also increasing. So a lot of things were going on around the world. Also in America itself, there were a lot of fights going on. According to the racism. So in some of the places, so the peoples are demolishing the shopping malls, and they were looting the daily things also, because so everybody knows that in America there is a lot of racism. So due to that, whatever the black people are there, they lost their jobs also. So as they don't have any jobs and money, they were looting the food items from the shopping malls by breaking them. Okay, fine. Now let's come to the next chapter, today's chapter. Pile foundations. Okay. So coming to the pile foundations. Look, we have been discussed a lot regarding to the shallow foundations, and I told you where to go for the shallow foundation and when to go for the shallow foundation. In the shallow foundation, again, isolated foundations, raft foundation, combined foundation, and strip foundation, means a strip footing. And we discussed a lot of theories in the case of the to determine the ultimate bearing capacity of the soil mass. Now, when do we go for the pile foundations? I have introduced the pile foundations in the previous chapter itself. Whenever the load coming from the structure is very high, or if the capacity of the soil is going to be very loose, means if the top soil has a less capacity to take the load, if the top soil has less capacity to take the load, then what you have to do is you need to go deeper in such a way that load should be transferred to a firm soil mass. Means if the top soil is going to be looser soil, then you go deeper and deeper to attain the firm soil mass. Then you transfer the load. See, ultimately our main aim is to transfer the load. How? Safely. To whom? Soil mass. So while you are going to transfer that load, we have to look over whether the soil is enough able to enough means enough to able to take that load or not. So then we go for the pile foundations. And in the case of the pile foundations also, see, throughout the soil mechanics and foundation engineering, we were seeing somewhere are here piles and piles and piles. There are a lot of piles and there is a lot of classification of these piles. So before going to the actual phenomena of the piles, let's see what are the different type of piles. First, let's go with classification of the piles. See, piles are going to be classified LIDA based on function, based on mechanism of load transfer, based on installation, based on displacement, based on function, based on mechanism of load transfer, based on installation, and based on the displacement. See. Yesterday's class notes is also opening, is it? And some of the people has mailed me that one or two students mailed me that class notes is not available to download. So is it difficult in downloading the PDF? PDF not open. Class notes is available easily. See, those people who are having problem with that, please update your app. Please update the Zoom app and please update the whatever the browser you are having. Please update those. If you update those, you will be having, because most of the people it's easy to download, right? Okay, I'll see that. I'll see during the break and I'll let you know. Yeah, I'll let you know about that. Means some of the students has taken means said me about this issue. I'll look into that. Now, coming to the first, based on the function. Based on function, there are different type of piles. Number one, compaction pile. Compaction piles. See, the purpose of the compaction piles is just simply to densify the loose granular soils, to densify the loose granular soils. See, if the granular soil, what is the meaning of granular soil? Cohesionless soil means gravels and sands, especially sands only, not gravels also. So if it is going to be loosest up to deeper depth, mind it, if the soil is going to be loose at a top layer, we can use shallow compactors like vibratory rollers or smooth wheel rollers or rammers. But if the soil is going to be soft up to deeper layers, then in order to densify them, densify means to compact them, we are going to use compaction piles. Mind it, these compaction piles are going to be suitable for granular soils only, not for cohesive soils. Next, second one, anchor piles. First, let me write down this, then I'll show you the figures also. This anchor piles is used to provide anchorage against horizontal pull from retaining wall or sheet piles. So to provide the anchorage against the horizontal pull from retaining wall or sheet piles. So now, if you see here, if you observe, see, this is a compaction pile. This is a compaction pile. In the case of the compaction pile, if this is a granular soil, whatever the soil is a granular soil, in order to densify the soil, we are going to drive this pile. We are going to drive or install this pile. So this is nothing but pile, Nana. This is a pile. So when you drive, now it is going to be densify the surrounding soil mass up to certain radius. Up to certain radius, it depends upon the different type of the soil mass. So generally, it is going to be 3.5 times of the dia of the pile. 3 times of the dia of the pile. So it is going to be densifies the surrounding soil mass. So when you apply the load, the soil surrounding is going to be densifies over here. Such a type of pile is known as a compaction pile. So compaction pile main aim is to densify granular soil mass. Now coming to the anchor pile, you see this question means this is the ground level and this is a ground level. In this ground level, if you observe, this is a water level. So there is going to be a water body, and whatever this is nothing but the soil mass, and this is a deck level. See, have you ever observed when any hydraulic structure or any waterfront structure? So just simply I can say this is a water front structure. And you see, this is nothing but a sheet pile wall or not? This is nothing but a sheet pile wall, right? So in the case of the sheet pile wall, you are going to provide a pile known as anchor pile. These are nothing but the anchor pile. So this anchor pile is going to be provide a resistance. This anchor pile is going to be provide a resistance or anchorage against the horizontal pull. Or in simple version, I'll write over here. Please have a look. Whatever these piles are known as anchor piles. Whatever these piles are known as anchor piles. So when the pile is about to rotate, means when the pile is going to be moving, then in order to resist, see, this pile starts to move in this direction. And this anchor is going to be resist the horizontal pull. So this anchor piles, the purpose of the anchor piles is, what is the purpose of the anchor piles? The purpose of the anchor piles is to resist or to provide anchorage from the horizontal pull away from the wall. So to provide anchorage against the horizontal pull from the wall, then you are going to use the anchor piles. You see, this is a sheet pile wall over here, and in order to provide the anchorage, you are going to provide a pile known as anchorage pile. This is nothing but the anchorage pile. Now, Next, third one, uplift piles. Uplift piles is, so uplift piles is to resist structure from uplift forces. So due to overturning, tension will develop in piles. We can call these piles as to resist the structure from uplift forces. We can call these piles as tension piles also. So anchor piles and tension piles are uplift piles. So these piles are going to be used to prevent the structure from uplift forces. I'll show you all the figures. Don't worry about that. Next, batter are inclined piles. Batter are inclined piles to resist large lateral forces. Example, wind force, seismic forces. Seismic means you know that earthquake forces. To resist the large lateral forces. And last one is fender or dolphin piles. To resist waterfront structures. Okay, fine. Fender or dolphin piles is going to be used to resist waterfront structures, against impact from ships. See, waterfront structures means dock areas. Look, dock and harbor areas are nothing but waterfront structures. Now, let's see all of these files. Okay. So fender are dolphin piles. Now, these are the various piles. First of all, compaction pile to densify the granular soil. Anchor piles to provide anchorage against the horizontal pull from the retaining wall. And tensioner uplift piles to resist the structure from the uplift forces due to overturning tension will develop. Batter or inclined piles to resist large lateral forces. And fender or dolphin piles to resist waterfront structures against impact. There is a possibility we use all the piles at the same time also. There is a possibility we use all the piles at the same time also. Now let's see what are those. Let's come to this figure again, once again. My dear students, you please observe. So this is nothing but the anchor piles I have provided you here. whatever this is nothing but the anchor piles. And these anchor piles are providing a resistance against the horizontal pull. And now you see, this is a waterfront structure, whatever this is nothing but pile cap now. And this is bridge pier. So this is a water level. And whatever this is nothing but the soil mass. I hope you can understand whatever the bridges we see, right? So we see in a river bodies, there is a bridges. And those bridges are going to be rested on the piers. Beneath the pier, what is the type of foundation you are going to see? The type of foundation you are going to see here is pile foundation. Now, my dear students, if it is there, then definitely there must be uplift force over here, Arna, and this is known as uplift force. And when there is uplift force, whatever these piles are there, Arna, these piles are going to be resist the uplift action. These piles are going to be resist the uplift action. If you observe, whatever these piles are now, these piles are known as tension or uplift piles. So let me repeat this again. So in the case of the water, means if this is a water river, right? This is a river. So the water will exert an uplift force on the pile cap. Yes or no? And this uplift force is going to be counteracted by the piles. So while the structure is going to be lift up, the pile will pull it down. Now, please tell me what is this action? Structure tries to lift up, pile will pull down. This action is known as a tension. Such a type of piles are known as a tension piles. Such a type of piles are known as tension piles. And you see, this is also going to be tension pile. You observe this structure due to the wind loads or seismic loads. This pile means this structure tries to overturn. When the structure is going to be tries to overturn, you observe over here, this tries to lift up and the pile will pull down. Whatever this is nothing but this is also going to be the tension piles. You see here you, if you observe, I have created whatever this is nothing but the uplift force, and these are going to be the uplift or anchor piles. We can call it as a, no, it's not uplift or anchor piles. It's a uplift or tension piles. And one more example I have provided over here is a transmission tower. In the case of the transmission tower, these are nothing but the wind loads are not. And now, due to this overturning, you please observe, due to this overturning over here, then the structure tries to lift up and this pile is going to be pulled down. So whatever the structure, whenever the structure tries to lift up, then the pile will be pulled down. Then whatever that pile is known as a uplift pile. So I hope you understood what is the meaning of uplift pile. Whenever there is a uplift force, whenever there is a uplift force, then in order to provide a tension, means in order to provide the anchorage from the uplift, we go for the tension piles. And now you see, I'll show you everything in this figure. Please have a look. This figure, whatever the last figure, see, this is a river. And this is harbor or deck structure, which is nothing but a waterfront structure. Now, everybody, when the ships are going to become, when the ships are going to become these ships will impact, means when the ships are going to be rest, they are going to give some impact or not. So when they give impact, in order to resist the impact from the ships, in order to resist the impact from the ships to the waterfront structure, we use fender or dolphin piles. Now, my dear student, whatever this is nothing but the fender or dolphin piles. I hope you observe. Whatever this is nothing but the fender or dolphin piles. So this is a pile which offers resistance against the impact from the ships. Whatever the pile I am showing you over here, which offers resistance against the impact from the ships, that is known as a fender pile. And whatever the pile that provides over here, which offers resistance from the horizontal pull, this is a horizontal pull or not, this is known as anchor pile. Then what is mean by batter piles are inclined pile. You see, this is an inclined pile, and this is also known as a batter pile. Why, sir? Sir, when the water flows, the water will flows in horizontal direction also. So this is also a water and this is also a water. I hope you understood. And whenever there is a lateral load by the water or wind, you are going to use the inclined or batter piles. So here also this is going to be the batter pile. And whatever this is nothing but the sheet pile wall. You know the meaning of sheet pile wall. And this is going to be the foundation pile. Look, in these figures, I am representing you foundation pile, compaction pile, anchor pile, tension or uplift pile, inclined pile, and a lot of examples for the tension piles. Most of the piles are tension piles only, that's why. And anchor pile, batter pile, fender pile. Fender are dolphin piles. Have a look once. Difference between uplift pile and tension pile. I said both are same. Right? Do you call deck structure as jetty? Yes, you can call. Deck means harbor areas. My dear anonymous attendees, sir, when will be the syllabus complete, sir? Probably today, and by tomorrow we'll be completing the pile foundations. Tomorrow after means tomorrow in first session, probably we'll be completing the pile foundations. And tomorrow in the second session, I'll be starting the soil exploration. Day after tomorrow. So for the gate syllabus, today is 4th. Tomorrow 5th and 6th. By 6th, up to sheet pile walls, means up to chapter number 19. Right now we are in chapter number 17, and the day after tomorrow means chapter number means 6th. June 6th, we will be completing the entire gate syllabus, and on that day, June 6th, in the first session before the break, we will be completing the syllabus, and after the break, from 11:30 to 2 o'clock, I will be taking the doubt clearing session for the gate. And in the 7th, exclusively for the IES only, whatever the extra syllabus for the IES, those are theoretical chapters only. Those theoretical chapters will be discussed exclusively on June 7th. So some two chapters are there, geosynthetics and means geomembranes and foundation on expansive soils. Those two chapters are exclusively for the IES, and the people who are taking data, and if you want to listen, you can listen also, but the IES people should have to listen the class on June 7th. So probably 4th, 5th, 6th. On June 6th, by first session, we will be completing the entire GATE syllabus. Okay. So now these are the different type of piles based on the function. Now you see now second one based on load transfer. Based on load transfer. See, based on the load transfer, wait for that. I have all the figures. I'll be showing you. These figures are there for you only. Wait. So don't be amateur. Now wait for a moment. So now, based on the load transfer. So see, this is the most important part for the design purpose. See, this is a function based upon the function. And now this is the most important part. How the load is going to be transferred through the soil mass. Number one, end bearing pile. This is nothing but the end bearing pile. You see the end bearing pile over here as, what is the meaning of end bearing, sir? You will observe whatever the load I am going to apply, that's Q, the load applied is going to be resisted and transferred through the base or end bearing of the pile. See, this is going to be present if the hard strata is going to be located. This is nothing but a hard strata. If the hard strata is going to be located at a reasonable depth, then whatever the load carrying capacity of the pile means, load carrying capacity of pile means this is nothing but pile, right? This is a pile. So load carrying capacity, I am a pile. My load carrying capacity means how much load I can take. How much load I can take depends upon the resistance offered by the soil mass at the base. So here, if hard strata is located at reasonable depth. If the hard strata is going to be located at reasonable depth, then the load carrying capacity of pile depends on end bearing resistance at pile tip, which means whatever the load carrying capacity, so the ultimate load carrying capacity of the pile, QU, U means ultimate. So whatever the maximum load that the pile can take. See, when you are driving the pile or when you are installing the pile, when you apply the load, the pile will move downwards, right? And now when the pile is going to be moving downwards from the base, it offers a resistance. And that resistance is known as end bearing resistance. So we call that one as a QB. What is this QB? QB means end bearing resistance. In the case of the end bearing piles, The ultimate load carrying capacity of the pile depends on the end bearing resistance. QB means bearing. QB means resistance to end bearing. QU means ultimate load carrying capacity. So then you are going to go for the end bearing piles. But normally we don't go for the end bearing piles because when you apply the load, while the pile is going to be moving, first of all, the soil mass next to the pile, I am a pile, whatever the soil next to the pile will generate some shear. Second one, friction piles. We can call this one as a floating piles also. Sir, why we call it as a floating pile, sir? Now see, if you observe, in the case of the end bearing pile, I have represented clearly there is a hard strata. There is a hard strata. But in the case of the floating pile, whatever the soil mass is nothing but a soft soil. Whatever the soil mass over here is nothing but a soft soil, which means if a hard strata is not located at reasonable depth, or if a pile is driven or in fact you don't know about the driven, right? So that's the reason why I am writing installed in a soft soil, the load carrying capacity of pile depends on skin frictional resistance. Skin frictional resistance between pile and soil along length of pile. Look, observe again. See, if there is a hard strata, then the resistance is going to be offered from the base. But if it is going to be soft soil mass, you observe, if it is going to be soft soil mass, then due to this, whatever the along the length of the pile, if along the length of the pile, between the pile and the soil mass, you can observe there is a friction or shear is going to be developed, and that is known as skin friction. That is known as skin friction. So load carrying capacity, ultimate load carrying capacity QU is equals to QS. So what is mean by QS, sir? I told you QB means end bearing resistance and QS means skin frictional resistance. So in the case of the friction piles, you see here QU is equals to QS. QU is equals to QS. This is going to be the friction pile. Now the last one is so this is known as friction piles or floating piles. QS. So in this case, now the third one is just a combination of these two combined piles. So what is the meaning of combined piles, sir? Whatever the ultimate load carrying capacity of this pile depends upon the both resistance from the base and resistance from the sides. So then you are going to call it as a QU is equals to QB plus QS. So here QB plus QS, and here QU is equals to QS, and here QU is equals to QB. So generally we go for either friction piles or combined piles. Either friction piles or combined piles, where QU is ultimate load carrying capacity of pile. QU is ultimate load carrying capacity of the pile. QB is end bearing resistance. End bearing resistance, and QS is skin friction resistance. So see, based upon the load transfer, we are going to divide the piles into end bearing, friction piles. In simple words, I am telling you, or if there is a hard strata, the entire resistance is going to be offered by the base. And if there is no hard strata, then along the length of the pile, there is a skin friction. And generally we go for the combined piles. Basically, the end bearing piles in reality or in practical, they are not going to be exist. End bearing piles, they are not going to be exist. I am telling you again and again. But generally we go for whom? Friction piles and combined piles. Friction piles and combined piles. So where QU is ultimate load carrying capacity of the pile and QB is end bearing resistance and skin resistance. Sir, what is meant by ultimate? I'm asking you one question. While you're driving the pile, the amount of the impact you give for the driving depends upon the denseness of the soil mass, or that means the strength of the soil mass. I hope you understood. The strength of the soil mass. Yes or no? Why, sir? Because if I am going to be strong enough, then I will resist more. When I resist more, then the pile will take more load. See, my dear students, the more the resistance offered by the soil mass, the more the load will be taken by the pile to penetrate. If the soil is going to be hard, is it easy for you to drive the pile that much? No, it will take more load, right? The more the resistance from the soil mass, means end bearing resistance and skin friction resistance, the more the load the pile will take, means ultimate load carrying capacity. I hope you understood. Sir, how much percentage of this going to be taking, sir, here? The proportion or percentage of this QB and QS depends upon the strength of the soil mass. You cannot say exactly QB and QS are going to be 50-50%. Okay. So in the case of the combined piles, the resistance is due to both the bearing and the skin friction. So now there comes next one. Based on installation. Based on installation. How we are going to install the pipe? Number one, driven piles. Number one, driven piles. Sir, how to design this type of piles, sir? Wait for that, sir. Driven piles. So now In the case of the driven piles, so driven piles means you are just drive the pile by using a pile driving and pile hammering equipment. See here, we can use a timber, concrete, steel piles, etc. are erected in position and driven into soil by pile driving equipment. Pile driving equipment. See, whatever, this is nothing but the driven piles. The driven piles are driven piles. Means you are going to drive the pile. Driven piles are timber or concrete or steel piles, etc. are erected in position. You are going to be erected in the position and driven into soil by pile driving equipment. Pile driving equipment means pile hammering, pile loading. Those are known as a pile driving equipments. These are known as a driven piles. And second one is bored cast in situ piles. So what is meant by bored cast in situ piles? First you listen this, then I will show you the figures also. See, driven pile means already you prepare the pile. Already you have a pile, whether it's a timber pile or concrete pile or steel pile, whatever it is, already you have prepared it in the factory, manufactured it. And then what you are going to do here is you take the pile, you keep in a proper position, and then you install by using the pile driving equipment. Now, the meaning of in situ, what is the meaning of in situ? In situ means field, right? So bored and cast the piles in the field. Bored and cast the piles in the field. In this, boreholes are dug by using borings. So by using borings and then steel, concrete is filled in holes. So driven piles are, you just prepare, means already there is a pile, and then you keep in a proper position, and then you are going to drive by using the pile driving equipment. Whereas in the case of bored cast in situ piles, first you dig a borehole. And then what you do is you keep the steel and the concrete. Then you attain, you leave it for some time. Then what happens? It attains the strength. So now let's see, I'll show you some figures. See, whatever I am showing you here, this is nothing but a pile driving equipment. I told you, right? This is nothing but the pile driving equipment. So here, this is going to be pile driving equipment. So now if you observe, this is nothing but a pile shaft. Pile shaft in position, and then by using this pile driving equipment, you are going to drive the pile into the ground level. This is a pile driving equipment. Now, if you observe, my dear student, you see whatever, this is nothing but this is going to be borehole or not. I hope you observe this. Whatever, this is nothing but a borehole. And once you dig the borehole by means of the borings, once you dig the borehole, see, this is it a well prepared or you are preparing in the field? We are. can I say this is nothing but bored borehole and then driven? Whatever this is nothing but the steel casing. Whatever this is nothing but the steel casing. So my dear, once you dig the borehole, then you are going to place the steel by means of the helical reinforcement. Whatever this is nothing but the helical reinforcement or not. So you place the steel up to certain depth and you fill the concrete. Whatever this is nothing but concrete or not. Yes or no? So here what I am showing you is, first of all, you dig a borehole. First of all, you dig a borehole and then you place the concrete. Once you place the concrete, once you place and then you place the steel and then you place the concrete. Such a type of piles are known as a bored cast in situ pile. Whatever this is nothing but bored cast in situ pile. First, we dig the boring. First, we do the boring and then we install the steel and then we are going to pour the concrete. I am showing you here figure wise. This is a bore and this is a steel casing and then we pour the concrete so that you can see this figure. The center figures are going to be after this one. So this is 1, this is 2, this is 3, 1, here it is going to be 2, this is 3 and this is going to be 4. After that you are going to make sure the concrete bed at the bottom also. So this is bored cast in situ pile. Now how you are going to prepare this one? You see the procedure of the bored cast in situ pile. Bored cast in situ pile. You please observe over here. So first of all, we are going to see this is nothing but boring. That is auger bore. That's a one type of the boring, auger boring to remove the soil mass. So first we are going to make sure the borehole. First we are going to make sure there is a borehole and then you remove the soil mass by means of the drilling. This is the phase 1. This is the phase 1. So in the case of the phase 2, we are going to withdraw the soil mass and then concreting. This is going to be concreting. And once you fill the concrete, see, either you fill steel first and then concrete, or you fill the concrete and then steel. You don't say, sir, if you fill the concrete, then it is going to be hardened. Mind it, Baba, concrete will harden with respect to time, not initially. So, and then you are going to place the steel. So these are phase 2 and phase 3 can be reversed. The phase 2 and phase 3 can be reversed. So these are going to be irreversible, means a reversible process. So now this is going to be the steel. Whatever the pile you are going to see here, first I dig a borehole. First I dig a borehole by means of the auger boring. I removed the soil and then I fill the concrete slowly up to the level and then I insert the steel. Such a type of pole is bored. First you dig boring and casting in situ in the field. Boring and casting in the field is known as a bored cast in situ pile. Now you see here, whatever this is nothing but the driven pile or not. You please observe. You see this is already prepared factory manufactured pile. This is already factory manufactured pile and then it is going to be driven by means of the pile driving equipment. So there is a pile driving equipment here itself. You see these are going to be the driven piles only, which has been already made in the field. Which has been already made in the field. See, you see this one. These are going to be the piles. These are the steel piles. And these are timber piles. And here you can observe, this is a concrete pile. And you know, this is nothing but the bored cast in situ pile. I'm showing you different views. This is a boring, right? Whatever this is boring means the subject is not boring. That hole is known as a boring borehole, or we can say it as a borehole. And this is going to be the steel casing, and then you pour the concrete over here. This is known as a bored cast in situ pile. I hope you understood different type of piles. So driven piles, this is nothing but timber pile, steel pile, concrete pile. By using the pile driving equipment, here it is there, right? This is also pile equipment over here. That's also pile equipment. See, I am showing you all these figures just for sake of. Yes. So now the last one, you see, this is nothing but the batter piles. Are inclined piles. Wherever you see the pile as inclined pile, then you can say it as batter piles or inclined piles. And is going to be the steel. You see the I sections, right? H shape. The steel is going to be used in the case of steel structures. You know, I sections, H sections, and all those things. Such type of sections are those. Now, one more thing is, the last one, driven cast in situ pile. Driven cast in situ piles. So the driven cast in situ piles, So now if you observe over here, in the case of the driven cast in situ piles, here a tube a steel tube fitted with driving shoe is driven into soil. A steel tube fitted with the driving shoe is driven into the soil and then filled with the concrete. See, there is a small difference in the bored cast in situ, driven cast in situ. Bored means you are going to dig a borehole. But in the case of the driven cast in situ pile, what happens, you see? You please observe. I showed you this is a bored cast in situ pile, and this is nothing but driven cast in situ. You please observe. This is a steel tube, and here, which is known as a driving shoe, Nana. This is known as driving shoe. So first of all, we drive this steel tube with the driving shoe. This driving shoe will penetrate into the soil mass. By driving means by chiseling concept, means by cut down the soil mass, it will penetrate into the soil. And then you fill this steel tube with the concrete. So the difference between the bored cast in situ and driven cast in situ is, in this we dig a borehole, and in this we are going to insert a steel tube with a driving shoe, and then slowly this is going to be filled with the concrete. I'll show you one more figure. You please look over here. Whatever this one, these are there, right? These are nothing but the steel tubes. And whatever these piles are known as a driven cast in situ piles. So these are known as the steel tubes. What are all these? Are known as the steel tubes. We drive the steel tube into the soil mass, and then you fill the steel tube and you fill the inside is going to be with the means you fill the inside of the steel tube with the concrete. So these are the different type of the piles. So steel pipe remain there or we remove it after pouring concrete. See, whatever the steel pipe means the steel tubes, they can be removed or they can keep it there itself. They can be either removed or they can be keep it there itself. So now I hope you understood this. So whatever, this is nothing but the driven cast in situ pile. This is a driven pile and this is a bored cast in situ pile. I have shown you all type of piles here itself. And at last, based on displacement, piles, these are nothing but the driven piles. Generally driven piles. Sir, what happens, sir? Sir, when you drive the pile, the surrounding soil gets disturbed or not? When you drive the pile, the surrounding soil will definitely gets disturbed. And moreover, if it is the clay, in the case of clay, when you drive means you're going to impart some energy or not? Keep that in your mind. When you are driving, you apply some load on the top, yes or no? Due to that load, the surrounding soil mass will get displaced. Means the surrounding soil mass will get disturbed. And if the soil mass is going to be clay soil mass, there is a possibility the soil will get remolded and lose the strength. So surrounding soil will get disturbed, and if soil is clay, it gets remolded. If the soil is going to be clay, it gets remolded and loses its strength, retains with respect to time. So this is known as a displacement piles. The slide is not visible. Whatever the slide I am writing, is it not visible to you? Okay. It's visible, right? Yeah. So at first, when you drive the pile, the soil will get disturbed and remolded, and with respect to time, it retains, which is nothing but thixotropy property. So these type of piles are not suitable for clayey soils. Then next one, non-displacement piles. Non-displacement piles. Generally, bored piles are non-displacement piles. See, displacement means when you drive, then due to that impact, the surrounding soil will get disturbed and it causes remolding in clay. But when you dig a borehole, then the surrounding soil mass will not get disturbed now. When you dig a borehole, the surrounding soil mass will not get disturbed. So these are the different type of the soils based upon the classification, means classification of piles based on function, based on mechanism, based on installation, and based on displacement. I have shown you with the figures over here. So once I share the PDF, you can go through all those things once again. Now let's come to the topic. Which type of installation technique is adopted on what conditions? I told you clearly the points over there. Wait for that. Driven piles. Whenever it's up to you. It's whatever is suitable to you. So I'll tell you at the end. Generally, we prefer the driven piles. We prefer the driven piles in the case of the granular soils. We prefer note. Prefer driven piles for granular soils and bored piles for clays or cohesive soils. Generally, we prefer driven piles for the granular soils and bored piles for the clays. Now, let's see the most important topic in this chapter. See, so far I have not discussed the chapter also. I have just said you what is the classification of the piles. Now, what we are going to do here is determination of ultimate load carrying capacity. What is meant by QU? Ultimate load carrying capacity. So we have different formulas. Static formulae, dynamic formulae, and a pile load test. Static formulae, dynamic formulae, and a pile load test. So these are the three things that we are going to discuss in this chapter to determine the ultimate load carrying capacity of the pile. So this is completely based upon the earlier load transfer mechanism. So now let's see one by one. Static formulae. So in the case of the static formulae, now let's draw a pile. In the case of the static formulae, see if this is the ground level and if the length of the soil mass is going to be L, which is nothing but embedment length. So this is a pile. This is a pile. And whatever the soil mass, forget about what type of soil it is, this is a soil mass, okay? Now, in the case of the static formulae, this formula works, or static formulae or analysis, we say it as static formulae or analysis, we call this as. So what happens over here is, this analysis is based on when, mind it, keep the points, I am writing the points also, keep listening. When the load is going to be applied on the pile, when a load is applied on the pile, initially this pile starts to move vertically downwards. Yes or no? When a load is applied on pile, it moves vertically downwards. And when it moves vertically downwards, then you see here, see, when the pile is moving downwards, then the soil will exert a shear or friction is going to be developed or not. So now, when the pile is going to be moving downwards, I am applying this load Q. When the load is going to be applied, the pile will move vertically downward. Then due to the shear or friction developed between the piles, due to the shear or friction developed between pile and soil, skin friction is mobilized. So point number one, you please observe, when a load is applied on a pile, it moves vertically downward. When it moves vertically downward, I am showing you here, when it is going to be moves vertically downward, then there is a shear or friction developed between the soil and the pile. Whatever, this is nothing but the pile, right? This is a soil. So due to this, skin friction is going to be mobilized. Now, as load gets increases, then skin friction resistance is going to be increases. As the loads gets increases, skin frictional resistance is going to be increased. Now, my dear student, look, I am going to apply the load, and when the load is going to be increases, then the skin frictional resistance is going to be increases along surface area of pile. What is the meaning of surface area? Perimeter into length or not? Means along the length of the pile, or surface area of the pile. Now, as the load is going to be increases and increases and increases, the skin friction is going to be mobilized and mobilized, and reaches maximum skin frictional resistance QS. So first, as load gets increases, the skin frictional resistance increases along surface area and reaches maximum skin frictional resistance. By the time it reaches over here, then whatever the resistance, this is going to be the QS. QS. Now, my dear students, what happens over here? I hope you understood the first 2 points. When a load is applied on the pile, it moves vertically downward due to shear, skin friction develop. And as load gets increases, then the skin friction resistance is going to be maximum. And at this point, Q is equals to QS. And at this point, and Q is equals to QS. And Q is equals to QS. Okay. Now, if load increases more than QS, which means Q greater than QS, then point R end bearing resistance is going to be developed. Point R end bearing resistance is developed. So what is the meaning of point R end bearing, sir? Now you see, sir, here at the base, point R end bearing resistance is going to be developed. If load is going to be more than, see, mind it, first the skin friction is going to be fully mobilized, and then if the load is going to be more than the skin friction, and then the point or end bearing resistance is going to be developed, comma, skin frictional resistance will fall from its maximum. Will fall from its maximum. See, when the load is going to be starts to penetrated, means by taken by the end bearing, then the skin frictional maximum is going to be dropped. So and as load gets increases further, the point bearing, end bearing resistance becomes maximum as QB. So whatever this is going to be now act as a QB. So I hope you understood now. So first of all, which one is going to be mobilized? Skin friction is going to be mobilized. And then which is going to be mobilized? Bearing resistance is going to be mobilized. So the note point here is when skin friction is fully mobilized, end bearing is not maximum, and when end bearing is fully mobilized, skin frictional resistance is less than maximum. So this is the point. First, it develops as a skin friction, and slowly at the end, it is going to be developed as an end bearing. So how many bearings are there? First QS and then QB. So my dear student, then the load is going to be the ultimate load. So then the maximum load that you are going to see here is, so according to the principle, QU is equals to QB plus QS. QU is equals to QB plus QS. So whatever the soil mass it is, I am not discussing about the type of soil. I just said as a soil mass, and whatever the ultimate load that the pile is going to be take is maximum skin friction and the maximum bearing resistance. So whatever the maximum skin friction and whatever the maximum bearing resistance, that is going to be the total load that the pile is going to be take. I hope you understood over here. Now, how to determine this bearing resistance and skin friction, sir? S means skin friction, B means bearing. Now, how we are going to find out here is FB AB plus FS AS. Look, this is nothing but a load. Q means that is known as a load. The meaning of Q is load. The meaning of the Q is going to be load. Okay. But in the previous chapter, now I am connecting with the previous chapter. My dear student, in the previous chapter, shallow foundations, have we considered any frictional resistance? There we consider only the base resistance, means bearing resistance or not. Whatever the discussion I made in chapter number 16 is bearing capacity. Their side resistance. What is mean by side resistance? Side resistance is nothing but skin frictional resistance is neglected in shallow foundations. There you took only the base resistance only. There we took only base resistance. Now I am going to take the base end bearing and sides skin friction. What we learned before in the previous chapter is the bearing capacity. The bearing capacity is a stress form. The bearing capacity is in the stress form. So now what I am discussing is load. When the load is there, I can write the load as a stress into area, right? I can write the load as a stress into area. So now what is this FB? Bearing capacity of soil at pile tip. Bearing capacity of the soil at a pile tip. So what is FB, sir? See, I am showing you here as a base. At the base, what is the base resistance is? The bearing capacity of the soil at a pile tip. Pile tip means this is the pile, which is going to be the tip bottom of the pile. And then we are going to find out the area AB as area at base. Similarly, FS, frictional resistance along surface area of pile, and AS, surface area of pile. Look, I am just converting. See, totally there are two components. Skin friction is there and bearing resistance is there. Now I am converting the bearing resistance into two parts. Means load is going to be stress into area. Which is stress? Bearing capacity into which area? Base area. If this is a pile, what is the base area? The base area is going to be looks like a pi by 4 d square. Keep that in your mind. What is the base area? What is the base area? See, I hope you can see this as a pile, right? Whatever it is, water bottle is just looks like a pile. And this is the base. And what is the base area? It has some diameter or not? What is the base area? The base area of the pile is going to be pi by 4 d square. And what is surface area, Nana? What is meant by surface area? Surface area means perimeter. What is the perimeter of a circle? Pi d into L. So surface area means perimeter into the length is known as a surface area. Skin friction develops along the surface area, whereas a bearing resistance, bearing capacity at the base. So whatever the bearing resistance over here is nothing but bearing capacity into base area, and skin friction is going to be frictional resistance into surface area. So where AB is equals to pi by 4 d square. If pile is circular, d dia of pile, and if it is going to be d square, if pile is square, d is side of pile. And what about AS, sir? AS is pi dl, circular, and 4dl square, where L is the length of embedment length of pile, which means how much length of pile is going to be actually embedded. See, this is also going to be a small portion of pile only, right? But this is not below the ground level. Whatever the length of pile below the ground level, that is nothing but the L, embedment length of the pile. I hope you understood over here. What is area? Please, areas. Areas are going to be pi by 4 d square and AS, surface area. Surface area means perimeter into length. What's the problem, right? Why consider it only circular? I did not consider it only circular. The most shape of the pile we prefer is circular. So board is not working properly. For me, the board is no problem. For you, there is a problem, which means I think you might have to restore your internet connections. Is it a problem with everyone? I'm asking you, does everyone has a whiteboard problem over here? Everything is okay, it's fine. No sir, no sir, no sir, no sir, no sir, no sir. It's going good, not at all, not at all. So my dear anonymous identity, I think you have to restore your next subject here. Next same subject anukuntunnaru. Arey bhai, anonymous identity, whatever the subject it is, it's going to be there or not. This is known as anxious disorder, anxiety disorder. Why to be so much anxious? Huh? Okay, fine. Stop. Okay, fine. Now you see, first of all, I'm dividing this as a whole. There are two portions of loads and I'm dividing the load into stress into area. And I know how to find out the area at the base and AS. So now let's see. Observe. FB is calculated as like Terzaghis equation only. FB is going to be calculated as like Terzaghis equation. So what is the Terzaghi equation, sir? Sir, you please tell me what is meant by FB? Bearing capacity of the soil. So FB is equals to QU, ultimate bearing capacity of the soil. See, please write down that equation. We know, right? FB is equals to QU is equals to CNC plus gamma DNQ plus 0.5 gamma B and gamma. 0.5 gamma B and gamma. So CNC plus gamma DNQ plus 0.5 gamma B and gamma. Okay. So this can be written as Q into NQ plus 0.5 gamma B and gamma. Please listen. Sir, if when frictional resistance is fully mobilized, then will bearing resistance will be zero at that instant? No, bearing resistance would be there, but it's not going to be maximum or zero. So CNC plus, now, my dear students, in deep foundation, depth is going to be very larger than the width. Then 0.5 gamma B and gamma is very less compared to Q is equals to gamma into D, or Q compared to Q. Sir, here Q, sir, you please remember what is Q over there? Gamma D, right? Now, my dear, whatever the surcharge over here, gamma into L. Yes or no? Whatever the surcharge over here, gamma into L. And here, whatever the point for gamma B, here, if you observe, this is gamma L, and this B is nothing but, in the case of square, side. And in the case of circle, that is going to be dia. You know, B is width of footing in square. And B is the diameter of the circle. So in the case of the deep foundation, as the depth of the footing is more than the width of the footing or dia of the footing, in deep foundations, then 0.5 gamma B n gamma is very less compared to Q. So neglect width or diameter effect. If I neglect, then what is FB now? The FB is equals to CNC plus QNQ. Please keep this aside. I'm going to discuss this later. So CNC plus QNQ. Okay. So this is the ultimate bearing capacity, which is nothing but the bearing capacity of the soil mass. Terzaghi is not applicable for the deep foundation, sir. That's the reason why, sir, I said the bearing capacity, not the skin frictional resistance. Now, so in the case of the clays, okay, in clays, phi u is equals to 0 degrees, then NQ is equals to 1, then FB is equals to CNC plus Q. Compared to here, Q is very less compared to CNC. Q is very less compared to CNC. See, because the NC value is going to be very high and cohesion is going to be more. In the case of clays, cohesion is going to be more and NC value is also going to be more. NC value lies between 6 to 10 for piles. Generally, we take NC as a 9. Generally, we take NC as 9. Don't say it as a average. So this is based upon the basics. Means based upon the experiments, it was observed. The NC value is going to be 9. So in the case of the clays, phi u is equals to 0 and NQ is equals to 1. Sir, then NC is equals to 5.7, sir. NC 5.7 according to Terzaghi. I said calculated as like Terzaghi's equation, but not apply the values of the Terzaghi. So now, if you see the final equation, Q is going to be neglected, then FB is equals to CNC plus Q. The Q is going to be neglected and NC is going to be 9. Then FB is equals to 9C, or I can directly write this one as a CNC C into NC. So my dear student, whatever this equation, finally, FB is equals to C into NC. Whatever this equation is going to be for whom? Clays. In the case of the clays, the bearing capacity FB is equals to CNC, where C is the cohesion at pile tip. Cohesion at pile tip. I hope you understood. So first of all, see, compared to this, see, the value of NC is equals to 9 and the C value is going to be somewhere 50 or 100. If it is a closed soil, 100, and 9 into 100, 900. 9 into 100, 900. And let's take gamma as a 20. Let's take gamma as 20. And let's take the length of the pile as 10. Let's take the length of the pile as 10 meters and gamma has 20, then what is the surcharge? 20 into 10, 200. But what is CNC? 9 into C value 100, 900. Compared to 900, 200 is going to be very, very less or not. So we neglect that. This is length L. So in the case of the clayey soils, we take FB as a CNC. We take FB as CNC. Now, in sands, in the case of the sands, cohesion is going to be 0. When cohesion is going to be 0, then FB is equals to QNQ. I'll write this as a sigma V dash into NQ. Sigma V dash into NQ. So now, if you observe over here, you just write this once. I'll explain you the remaining things later. See what is mean by Q? Surcharge, right? So here, whatever, if there is a water table, then there is going to be the effective stress only, right? Sigma V dash is effective vertical stress at pile tip. So this is the bearing capacity. So first, I find out the bearing capacity in the case of clays. See, this is the generalized equation or normal equation. This is the normal equation. And in the case of clays, we say it as a CNC. And in the case of the sands, we call it as a sigma V dash into NQ. And now, see, okay, fine. I have explained AB, I have explained AS, I have explained FB. Now, what is there? What is going to be present over here is a FS. I am dividing part to part. I am making a kaima over here and then I will make it as a curry also later. So don't worry. I am going to provide you first the FB, FS, AB and AS. Then I will explain you each and every point by taking as a whole. So don't worry about that. Mr. Anonymous Identity, why you are simply neglecting all the things, sir? Simply just like that. I am not neglecting, my dear student. There were a lot of scientists. The scientists were like basics, Prandtl, Hansens. A lot of scientists were there based upon their assumptions, and they said that the Q value is going to be less than the CNC. This is not the one that I am going to neglect. Don't think I am a Carl Terzaghi or I am a father of the soil mechanics. So based upon the experimental data, they mentioned that the scientists mentioned that Q is very less compared to CNC. In the case of deep foundations only, keep that in mind. Okay, fine. I'll write that also. In deep foundation. Sir, why you are not neglecting the previous is that is going to be shallow foundations. Is the type of questions you want to ask? Okay. So now, coming to the FB, sigma V dash into NQ. Let's come to the next one, FS. Skin frictional resistance. See the skin frictional resistance, just like it's look like a shear strength or not. Just like it's look like a shear strength. Here, the shear strength, you know that the shear strength equation, right? Fs is equals to C plus sigma into tan phi. But now I am going to write this equation. See this skin friction. Friction means a shear strength only. What is meant by frictional resistance? The frictional resistance is nothing but shear strength, but the change is this is Ca and this is a sigma H bar and this is going to be delta. This is going to be delta. Sir, what is this Ca, sir? Sir, what is meant by cohesion? Please tell me first of all. What is the definition of cohesion? What is the definition of the cohesion? Cohesion means attraction between same molecules. Yes or no? If the attraction is between soil and soil, that is going to be cohesion. But here there is an attraction between whom? This is a pile and this is a soil. So when there is attraction between two different molecules, can I say it as a cohesion or adhesion? Cohesion or adhesion? You please tell me. This is a pile and this is a soil. This is a pile. The attraction between two different molecules is going to be adhesion. So now where Ca is adhesion between soil and pile along length. Soil and pile along length. So then you how to find out the Ca, sir? It is going to be mentioned as alpha into C bar, where alpha is known as adhesion or shear mobilization factor. Adhesion or shear mobilization factor, and C dash is average cohesion along length of pile. So first one, please observe. After all these many chapters, you people are asking what is meant by mobilization. What is meant by mobilization, right? Developed. So shear mobilization factor means what is the factor that develops? Means how much percentage? Alpha means the percentage. 0.5, 50% of the shear is going to be developed. 0.8, 80% is going to be developed. So this alpha is going to be ranges from smaller values to larger values. Generally, the alpha of the stiff clays is less than the alpha of the soft clay, because soft clay offers more adhesion. Means soft clay means it is going to be adheres to the hand or not. If I give you stiff clay, does the stiff clay will adhere to your hand? This is your hand. I give you hard clay, means stiff clay and soft clay. You keep the soft clay and you keep the hard clay. Which will have more adhesion? Soft, because that will adhere to the palm. So alpha of the stiff clay is going to be less than the alpha of the soft clay. Now, coming to the next one, in this sigma H dash is average. H means lateral earth pressure on pile, and this sigma H dash can be given as K into sigma V dash. K into sigma V dash, where K is known as coefficient of earth pressure. Coefficient of earth pressure, and sigma V dash is known as average vertical stress. See, this dash is different and this is bar. Average vertical stress along pile. Whatever the average vertical stress along the pile. See, this sigma V dash means effective vertical stress, and sigma V dash means V bar means average vertical stress along the pile, and where delta is friction angle between pile and soil. Generally we take a delta is equals to 5. Generally we take delta is equals to 5. See the same equation, C plus sigma into tan phi. This time I am going to write C as a Ca as adhesion, and that adhesion is going to be written as a Ca alpha into C dash. And similarly, this vertical stress, as it is going to be sheared along a vertical plane, then you have to take the lateral stress sigma H dash. average lateral earth pressure, and that average lateral earth pressure can be find out that K into sigma V bar, where K coefficient of earth pressure into sigma V bar average vertical stress. So now if I write the final equation over here, so Fs is equals to alpha into C bar plus K into sigma V bar into tan delta. So this is the final equation, and so Fs is equals to alpha into C bar plus K into sigma V bar into tan delta. Now in clay, phi is equals to 0 is equals to delta. Then Fs is equals to alpha into C bar. As I told you, the delta is nothing but phi, right? And in science, C is equals to 0. So Fs is equals to K into sigma V bar into tan delta. Look, I have explained you each and everything. So finally, this is the whole equation for Fs. And now I applied the conditions. The applied conditions are, in the case of clays, Fs, and in the case of the sands are Fs. So finally, you need to know, see if you remember this equation, then you can write for clays and sands. And similarly over here, if you remember this equation, you can write for clays and sands. So now this is a static analysis. So I divided into part two part. Now I'll write the whole. How? Let's see. In the case of clays, how it will be, and in the case of the sands, how it will be. I'll explain you completely over here, please. Especially. First, if the soil is a clayey soil, if the soil is a clayey soil, go back. See why these many doubts are going to become. Don't you wait for that? Don't you wait for that? And you see, you always tries to like due to this only. See, I told you an example. Until or unless the movie is going to be completed, you don't know what the exact point in that movie. Just because of you watch 30 minutes or 1 hour or just before the interval, you cannot decide the movie. Wait for that. I did not complete the theory, right? Once I complete, then if you ask us, there is some reason behind that. But instead of that, sir, why we are neglecting, why we are not neglecting, these things are important for you. It's not about I'm getting angry or something else. It's about the basic common sense. After all, this is the 34th day we are. So now, are you showing us movie here? Yes. If you don't want to see this movie, you can please log out and you can go out. My dear anonymous attendee. So now, if you come look over here, in the case of the clay soil, let's take for better understanding, I'll take a layered clay soil deposit. In questions they will mention there is a shallow foundation or deep foundation, so you don't need to worry. Now, if there is a hard strata, located. So if you observe, I am taking a layer deposit of the clay. Let's say the length of the pile. This is the length of the pile. The length of the pile as L, and you see this. This is the pile tip, right? This is the pile tip. So let's first now let's see. This is the clay soil mass. I'm going to apply the soil mass as a first. This is going to be C1 clay soil mass, and this entire soil has a position as a C2. And now this soil mass, in this soil mass, the length of the pile is going to be L1. Whatever the length from here to here, this is L1, and from here to here, this is going to be L2. See, what is this L1 means? The portion of length in soil 1 and portion of length in the soil 2. This is going to be the total soil hard strata. Now, my dear student, when you apply the load, as the load increases, then the shear resistance is going to be there, and this is nothing but the shearing resistance, and at the base there is going to be the QB, on the sides there is a QS. So please listen to here, at least show some good movie. If you don't feel this good movie, see, I don't know who's this type of people. If you are dare enough, instead of removing the anonymous identity, you please say your details, then I'll come to you. Okay, just because of you have something in typing, do you think you are going to talk whatever you want to talk? Do you dare? If there is an offline class, do you dare that? If you are dare enough, you please log in, means you please mail your all the details to me. Then I'll show you the actual movie to you. If you feel these classes are just like your BTech classes, I'm telling you, I don't need to say that also. So now you observe QU is equals to QB plus QS, where QU is equals to FBAB plus FSAS. QU is equals to FBAB plus FSAS. Okay. So now, whatever the things I have written earlier, in the case of the clays, I told you the FB is nothing but CNC, and Fs is already going to be there, alpha into C dash. You please look over here. I explained you all these things clearly. So what is FB, please? FB is equals to C into NC, and Fs is going to be alpha into C bar. So now, if you write down this equation, then what is the final equation you are going to get over here is QU is equals to C into NC into area at the base plus alpha into C bar into AS. So this is the final equation that we are going to use in the case of the clays. in the case of the class. So see, I explained you one by one. Apart from that, I explained you one by one FB, FS, AB, ANS. Now I am including everything into a single formula. I hope you understood why I took FB as CNC, cohesion effect, and why I took FB means FS as alpha into C bar, because I said you in the case of place 50, then delta is equals to 0. Sir, here, what is NC value? Please tell me. The NC value is going to be 9, my dear. Here, NC is equals to 9. And what about AB, sir? AB is equals to pi by 4 d square. What is D? If D is the dia of the pile and L is the length of the pile, D means dia of the pile. If you want me to write, I can write that also. And what about AS? AS is going to be pi dl. Pi dl. And now, coming to the remaining things, if you see this equation, NC, AB, AS, and alpha is there. What is C and what is C bar? Please tell me here. What is C value and what is C bar value? So from the given, C is nothing but C2, because I told you C means the cohesion at the pile tip. C means cohesion at the pile tip. Keep that in your mind. The C means cohesion at the pile tip. I have written here. Where is the point? Yeah. So what is meant by C? Cohesion at the pile tip. And what about C bar, sir? What is meant by C bar? Average cohesion along the length of the pile. So that average cohesion is known as a weighted average C1 L1 plus C2 L2 by total length. This is known as weighted average along pile. And this is going to be at a pile tip. So now I hope you understood how to determine the CNC, what is NC, what is C value, what is C bar value, and all those things. I explained the things separately. Now I am giving you everything as a whole fashion so that you can understand. Yes, length is there, right? Yes, the length is there. See, why I took the average, weighted average is the L1 and the other portion is going to be having a L2. So as a different lengths are going to be there, you have to take it as weighted average, my dear. You have to take it as weighted average. Sir, what if the soil is going to be uniform soil? What if the soil is going to be uniform soil? In the case of uniform soil, what is the meaning of uniform soil? Total cohesion is going to be same, right? In the case of the uniform soil, yeah. So if the soil is going to be uniform, in uniform C bar is equals to C and C is equals to C bar. Both are going to be same. No, that's it. So I hope you understood this. Now similarly, let's see for the sands. In the case of the sands, in the case of sands, now if you observe in sands, what happens? Please tell me again. In the case of the science, what happens here is again, you tell me QU is nothing but whatever the QU is nothing but QB plus QS, which is going to be FB AB plus FS AS, where FB is. So in the case of science, what is FB? Sigma V dash into NQ, where FB is going to be sigma V dash into NQ, and Fs is equals to K into sigma V bar into tan delta. If you have any doubt, you please go back. I have given you the values over here. So now, what is the sigma V bar and what is this value? So now QU is equals to sigma V dash into NQ into AB plus K into sigma V bar into tan delta into AS. See, why I discussed earlier not this fashion and separately is, if you remember separately, then you can write down the equation total. But if you do remember the total equation, then I'm telling you definitely you're going to be fall somewhere, a pitfalls would be there. So now, in the case of the sandy soil masses, now what is sigma V dash? You see, first let us see, this NQ depends upon the phi value. This NQ depends upon the phi value. You know that delta is nothing but phi. So this NQ depends upon the phi value. And AB, you know how to find it out. AB, pi by 4 d square. And K, they will give you. Delta, they have given. And AS, you can find out pi real. What is K? Coefficient of lateral earth pressure. So I have everything except these two. Yes or no? I have NQ, I have AB, K, delta, AS. But except these two, we required sigma V dash and sigma V bar. So now let's see, what are those? Okay, what is the sigma V bar, sir? Sigma V bar is nothing but gamma dash. Let's say if there is a water table, gamma dash into, now there is a one length over here, gamma dash into DC. Gamma dash into DC. Keep that in your mind. Now I'm going to say one more point. Please listen over here. So gamma dash into DC when length of the pile is more than DC. And gamma dash into L when length of the pile is going to be less than DC. So DC is known as critical length of pile. Sir, what is the meaning of this one, sir? Sir, if I draw the pressure distribution, the meaning of the pressure distribution is going to be, you see, you know that generally as you go deeper, the stress is going to be increases. Yes or no? Yes, the stress will increases. As you go deeper, the stress will increases up to certain depth only, and then the stress starts to remains constant. And then the stress starts to remains constant. So whatever the point that you are going to see over here, whatever the point that we are going to see over here, now if you observe, look, so here in this case 0, and now whatever the depth we are representing here, this is known as a DC. If this is DC, then what about this value over here? Gamma dash into DC. And what about here? Gamma dash into DC. So I told you, my dear, the sigma V dash means vertical stress at pile tip. So this is a pile tip. At a pile tip, what is the vertical stress? Gamma dash into DC. Now I know might be having a question, sir, why the vertical stress is going to be varying up to DC and remaining not DC. So now the point is, listen, in granular soils, especially in sands, vertical stress varies linearly up to DC and remains constant due to arching effect. Due to arching effect. Sir, what is meant by arching effect, sir? Arching effect means arching effect. Arching effect means load transfer between two bodies of different stiffness. So load transfer between two bodies of different stiffness. You see, this is a pile and this is going to be the soil. Yes. So pile is there and there is a soil. Now, this is going to be pile. What about here is going to be soil? Soil is different, pile is different. And this pile and the soil has a two different denseness. Means a two different stiffness. What is meant by stiffness, sir? Stiffness means a resistance against deformation is known as a stiffness. So now when you apply the load, this load will travel between pile to the soil mass. And whenever there is a load transfer, the arching effect comes into the existence. And due to this arching effect, what happens is the vertical stress varies linearly up to DC and then remains constant. The point is going to be due to arching effect, mind it. And this DC is equals to 10 times of the dia of pile. This DC is equals to, so not 10 times, 15 times of dia of pile in the case of loose sand. And DC is equals to 20 times of dia of pile in the case of dense sand. So DC is equals to, what is meant by DC? The DC means a critical length of the pile. So why? The reason behind is going to be arching effect. Why you are going to see the varies linearly up to DC is going to be arching effect. If the length is going to be, if the length of the pile is going to be less than DC, then up to length it is going to be varies linearly. So gamma dash into L. So now this is how you need to find out the sigma V dash. What is sigma V dash? Gamma dash into DC. The point is this DC means critical length of the pile, and this DC is going to be 15 times of dia of the pile, where D is dia of pile. Now, what is a sigma V dash, sir? Sigma A dash. Now, sigma V dash is average vertical stress. So what is average, sir? Look, this is going to be L minus DC or not? Whatever this length is going to be L minus DC. My dear student, first of all, the average means in the DC depth, what is the average, please? At the top 0 and at bottom gamma dash into DC by 2. See, question number 1. Does the variation, total variation is linear? No. Up to DC length, the variation is linear. And then remaining L minus DC, this is going to be uniform. Then what is the average value of the sigma V dash in this DC? What is the average? Average means top plus bottom by 2. 0 plus gamma dash into DC by 2. Up to what length? Up to DC. Up to DC. Sigma V bar. Sigma V bar is equals to 0 plus gamma dash into DC by 2 up to DC. So that, can I write the average over here directly as what is the average? Gamma dash into DC by 2 into DC. The average, weighted average you have to take now. The average in this zone up to DC is going to be gamma dash into DC. See, what is the average? What is the average? If I ask you up to DC, what is the average? The average is going to be gamma dash into DC by 2. Because that's a triangular variation, right? The average is going to be top 0 plus bottom gamma dash into DC by 2. And beyond this, in the L minus DC, what is average? Here, everywhere the value is going to be same or not? As everywhere the value is same, average is also going to be same. So up to DC, gamma dash into DC by 2 plus gamma dash into DC into L minus DC by, what is the total length? L. So this is the weighted average. Again, this is known as weighted average from stress distribution. So that's about the total conditions. I hope you understood. So you please go through these points once again. This is the final equation C. I know it will be a bit difficult to remember. That's the reason why I divided into a part to part so that you can understand much more better. So that's about the science over here. So please go through this. Meanwhile, we'll have a break. Meanwhile, we'll have a break. Please go through this once again. Value of DC would be given in this question. Yes, they will give the question. Limbasia, can you repeat arching effect? Arching effect means the transfer of load from one body to other body due to the difference in the stiffness. So why did you not take sand in the layered deposit? That is going to be much more complex. That's the reason why I did not took. Whiteboard is not working and I am using updated version of Zoom sir. See, my dear Anonymous, it is not a problem for each and everyone. So I don't know what to do. Means what help I can do for you that. So have a break and come by 11:40. Okay. Now it's back. So now we are going to discuss about some problems regarding to here. So now let's see the problems. So these are the classroom practice questions. Classroom practice questions. Now, in these classroom practice questions, a board pile, and I want to write one more point over here. The note point is arching effect cannot be seen in clayey soils. Arching effect is going to be present only in the case of the sandy soils, and bored piles has more frictional resistance than driven piles, which means QS of bored is greater than QS of driven piles. And what about the end bearing, sir? End bearing depends upon the base resistance, but skin friction depends upon the shear and friction between the pile and soil or not. Okay. So now let's come to the CRPQ. In the case of this, a bored concrete pile of 30 centimeters diameter. What is the diameter of the pile? 30 centimeters, which is going to be 0.3 meter, and length of 6.5 meters is subjected to seasonal shrinkage and swelling up to a depth of 1.5. So now we are going to in a stiff fissured clay. Fissured means cracks. So now let's take a same figure. So you please observe over here. Now there is a fissured clay and cracks are going to be present. Cracks are going to be present. Okay. So now the cracks are going to be present up to 1.5 meters. So now the contact of the pile is, this is the contact of the pile with the soil mass. So the average undrained shear strength of the clay is 50 kilopascals up to pile tip. Keep that in your mind. Understand this, up to pile tip. So from this point to this point up to pile tip, what is the average undrained shear strength is going to be 50 kilopascals. And the 100 kilopascals below the pile tip. What is the meaning of C, please? What is the meaning of here? C is going to be cohesion at pile tip, whereas C dash means average cohesion along the length of pile. Average cohesion along the length of pile. So now up to pile tip, this is going to be 50. C bar is going to be 50 kilopascals. At the pile tip, they have given the C bar, C value is equals to 100 kilopascals at the pile tip. So C is equals to 100 kilopascals. Now find the ultimate load carrying capacity assuming adhesion factor. What is the adhesion factor I have given you? Adhesion factor is going to be 0.3. Neglect top 1.5 meters. Look, whenever there is a seasonal shrinkage and swelling, you please neglect that depth. If they do give or if they don't give, whenever there is a seasonal shrinkage and swelling up to 1.5, remove that. Then what is the length? The length is going to be total 6.5 minus, remove that 1.5. What is the length? 5 meters. So my dear students, what you say here is this is going to be clay soil. So now for clays, QU is equals to FB. What is FB? CNC into AB plus alpha into C bar into AS. CNC into area pi by 4 D square plus alpha into C bar into pi DL. So neglect, they mentioned the neglect of 1.5. And you know that NC is nothing but 9, right? If they don't mention also, you know NC is equals to 9. 100 into 9 into pi by 4 into D value 0.3 square plus alpha 0.3 into C bar 50 into pi into D value 0.3 into L 5. So now you please substitute and let me know the ultimate load carrying capacity of pi. Ultimate load carrying capacity of the pi. So please tell me. So cohesion should be always half of undrained shear strength. Cohesion is a half of unconfined compressive strength. Unconfined compressive strength is QU, is going to be half of CU. But that they given as a shear strength. How 9 comes? You please go back. I said you. So what is the answer? 134 or 134.30. Is it 134 kilonewtons? Is it? Is it true? Let me check that. 5 by 4 into 0.3 square into 9 into 100 plus 0.3 into 50 into 5 into 0.3 into 5. 134.30 kilonewtons. That's the answer. So now, yes, I hope you understood this. If you have understood this one, now let's go back to the next question. Sir, if it is not told in the question to ignore, then what we have to? Yes, if they don't say also, you have to neglect, because that's a seasonal shrinkage. Due to shrinkage and swelling, there is no contact between the soil and the pile. Due to shrinkage and swelling, no contact of the soil. Some of the people are asking me to show the previous slide, so that's why I'm showing this one. So what if they give swelling, differential and seasonal shrinkage? When there is a swelling, there must be seasonal. Means what is the meaning of seasonal? When they are in the rainy season, swelling, summer season, shrinkage. So that is known as seasonal swelling and shrinkage. The pile tip means this is a pile tip, right? This is a pile tip. Is also doubt. Now let's see the next question. It's a GATE 1998, but you see. So now estimate the safe load carrying capacity. This time they're asking safe load. See the safe load. I will write here itself. Safe or allowable load. Safe or allowable load carrying capacity QS is equals to ultimate load by factor of safety. In the case of the pile foundation, the factor of safety is going to be 2.5 to 4. In the case of the pile foundation, factor of safety is going to be 2.5 to 4. So now how to determine the allowable or safe load carrying capacity? Let's see this question. Safe load carrying capacity of a single bored pile. We are discussing about single piles, mind it. And whatever, this is nothing but a bored pile. So what is the length of the pile? Length is going to be 20 meters long. And what is the dia of the pile? 0.5 meter, which means 500 mm. Na? Alpha as 0.4 and take the factor of safety as 2.5. I'm asking you QS. I gave you a layer deposit over here. I gave you a layer deposit over here, and if you observe, yes. So now, everybody, if you see, this is the data that we got from the soil exploration data, and that we see in the next chapter. So this is known as soil exploration data. By conducting the soil exploration, we got these values from 0 to 5 meters. From 0 to 5 meters, which means in the first 5 meters, the soil is a loose fill. And what is the meaning of undrained shear strength? Undrained shear strength is nothing but Cu. So the C1 value is going to be 50 kilopascals. 50 kilopascals. This is 0 meters and this is going to be 5 meters elevation. And now the next 5 to 10 meters, which means in the next 5 meters, there is a weathered over consolidated clay. Weathered clay. So what is C2 value here? 70 kilopascals. Next, from 10 to 15 meters, you see this is going to be 15 meters. What is this over consolidated clay, OCC? The C3 is going to be 100 kilopascals. And from 15 to 30 meters, in this entire zone, from 15 to 30 meters, what is this C4 value? 200 kilopascals. But what is the length of pile we are going to embed? The length is going to be only 20 meters, right? The length is going to be only 20 meters. So my dear student, if you observe over here, our point is up to 20 meters only. Now this is 5 meters, this is 5 meters, this is 5 meters, and up to pile tip, whatever, this is nothing but 5 meters. So what is the total length of the pile? 20. But the soil is going to be from 0 to 30 meters elevation they have given. So, and this is going to be heavily over consolidated clay. So these are the details they mentioned. Now, how to determine the safe load carrying capacity? If this is the question, the safe load carrying capacity is nothing but ultimate load by factor of safety. First of all, you find out the ultimate load, please. So what type of soil it is? Everywhere this is going to be undrained shear strength, means clay soil mass, right? Must have a figure over here. So I gave you 4 layers. Yes. So now, solution QU is equals to CNC into pi by 4 d square into alpha into C bar into pi dl. See, I have everything. I have d, I have l, I have alpha. I have alpha, I have d, I have l, and d is there, and NC is going to be 9. Now, C, what is C? C is cohesion at pile tip. What is the cohesion at pile tip? C is equals to C4 is equals to 200 kilopascals. You please observe. What is the cohesion at the pile tip? This is a pile tip, right? Whatever the cohesion at the pile tip is known as a C is equals to C4, whereas C bar is going to be average cohesion along length. So you know that C bar is equals to C1 L1 plus C2 L2 plus C4 L4, because there are 4 layers, right? By what is the total length of the pipe? Now you see, you know, this is 5 meters, 5 meters, 5 meters. Everywhere the length is going to be 5 meters, or along the length of the pile, along the length of the pile. See, don't take the last one as a 15 meters. Now, if you solve, so what is C1, please? C1 is 50 into 5 plus 70 into 5 plus 100 into 5 plus 200 into 5 by what is the total length? The total length is going to be 20 meters. I hope this is going to be 105 kilopascals. 50 into 5 plus 50 plus 70 plus 100 plus 200 into 5 by 20. Yes, 105 kilopascals. Now you simply substitute the values. So what is QU? C bar 200 into 9 into pi by 4 into what is the dia? What's the dia given? 0.5. 0.5 square plus alpha 0.4 into C bar. What is C bar? Yes, C bar is given as 105 into pi DL. D 0.5 into L as 20 meters. So you please find out the ultimate load carrying capacity. Which is going to be 1672.89 kilonewtons, and safe load is going to be ultimate load by factor of safety 1672.89 by what is the factor of safety? 2.5, which is going to be the safe load as 669.16 kilonewtons. 669.16 kilonewtons. So 17th page, there is nothing, sir. Okay, sir. So why you take that total 15 meters, sir, at the end? Are Baba, our main aim is along the length of pile from here to here only. Whatever below, we don't care. Okay, fine. See, whatever the figure, they have given 4 layers: loose fill, weathered clay, OCC, and heavily over consolidated. And from the first 0 to 15, 5 meters, 50, 5 to 10 meters, 70, 10 to 15. These are the elevation levels. I'll write that. Elevation level. This is elevation level. EL means elevation. So the elevation level is going to be 10 meters, 15 meters. So here OCC 15 to 30, heavily OCC. But the length of the pile is up to how many meters? 20 meters only, the length of pile. So our point is the skin friction develops up to 20 meters only. So in the first 5 meters, this is cohesion. Second 5 meters, this is cohesion. Third 5, this is cohesion. And fourth 5, this is the cohesion. Yes, C4 is going to be acting up to 15 meters. Yes. So did separate layers in shear zone, I can get same answer instead of taking weighted average. Yes, you can get, but that is going to be too much lengthy. That's going to be lengthy. I hope you understood now. That's it. Sir, if pile length was 15 meters, then what would be the cohesion at pile tip? Then you tell me, if the pile length is going to be exactly 15 meters, then this is the pile tip, right? Then still it is going to be C4. Then still it is going to be C4. We took length as 20 meters. You see, this is the length. The length of the pile is going to be 20 meters. Why we call static is whatever the load we applied is nothing but static loads. With respect to time, slowly, gradually we apply. Okay, now let's see the next question, please. Okay. A 12-meter long, 300 mm dia concrete pipe. Now this time, you see, a 12-meter long, 300 mm dia concrete pipe. So length of the pile is going to be 12 meters. Dia is going to be 0.3 meters. Phi is going to be 40 degrees, which is going to be delta. Water table is very much down and not likely to rise in future. So no effect of water table. And dry unit weight given as 18. The dry unit weight gamma D is given as 18 kilonewton per meter cube. And NQ is given as 137. Calculate the safe load carrying capacity. And factor of safety is given as 2.5. Now some of the students have asked, sir, does critical length will be given or not? Yes. So they have given, you see that whatever the critical length DC is given as 15 times of dia, which means 15 into 0.3, 4.5 meters. And K value for soil mass is going to be 2. So now you please observe here. Now, in the case of the pile, so let's draw the figure again. Okay. So now you see a 12-meter length, a 12-meter long. So L is given as 12 meters. Uniform deposit. Water table is going to be much likely to be not rise. So now they have given that DC value. What is the length over here? 12 meters. Yes. First of all, let's draw the pressure distribution. If I draw the pressure distribution, I told you up to DC, the value is going to be varies linearly, and then it is going to be constant. See, this is a sandy deposit or not? What is the type of deposit over here? Sand. So sand, in the case of the sand, due to arching effect, the stress is going to be linear up to DC only. This is DC. What is DC? We got 4.5 meters. And remaining is going to be 12 minus 4.5, which is going to be 7.5 meters. Okay. And mind it, there is no water table, right? When there is no water table, so whatever the unit weight I have given, this is going to be gamma D into DC. And here also gamma D into DC. Yes or no? First, let's write down the equation. Let's write down the equation. QU is equals to, what is FB in the case of clays? Sigma V dash into NQ into AB plus sigma A dash into K into sigma A dash into I can write sigma V bar into tan delta into A. Okay. First of all, what is sigma V bar? Yet pile tip. So sigma V bar is equals to gamma D into DC, which is going to be, what is gamma D I have given? 18 into 4.5. Come on, please tell me this value. 18 into 4.5. 18 into 4.5, which is going to be 81. So this value is 81 and this is going to be 81. And this is going to be 0 at top. Now, what is the average vertical stress? The average vertical stress, you see, at the top this is going to be 0. At this point, this is going to be 81. In this zone of 4.5 meters, what is the average? In the zone of 4.5 meters, what is the average? A plus B by 2, 0 plus 81 by 2, 81 by 2 into 4.5 meters plus. And in the remaining zone, in the 7.5 meter, the value is going to be same, right? Average is going to be 81 into 7.5 by what is the total length over here? 12 meters. Means I use different conventions. So here I used sigma V bar so that you don't need to worry about. This bar represents average and this represents at pile tip. Okay. So now can you please tell me what is its values? So this is going to be 65.81 kilopascals. Now, my dear, please substitute. The QU is equals to 81 into what is NQ I have given? 137 into pi by 4. D value how much? 0.3 square plus, what is the K value, please? What's the K value? K value is given as 2 into sigma 65.81 into tan delta 40 degrees into pi into what is the D value? 3 into what is L value? 12. So please find out the QU value. What is QU value? 2 into 65.81 into tan 40 into pi into 0.3 into 12 plus 81 into 13 into 37 into pi into 0.3 square into 0.2. So I hope this is going to be 2033.47. Then the safe load is equals to 2033.47 by 2.5. Answer is going to be 813.39 kilonewton. This is the answer. This is the answer. So you know that QS is going to be QU by factor of safety. That is how much. So we got the QU value and then we can find out the QS value as 813.39. Please have a look. Mr. Kaushik sir, why don't you consider the net ultimate in the safe bearing capacity? See, Kaushik, the analysis in the Terzaghi is different. Here in the case of the pile foundations is different. There the side resistance is neglected, so we take it as just a self weight. But here it is not going to be taken as self weight, so we don't consider that. We have to apply the factor of safety for everything. Sir, can they give underline by sand or overline by sand? Yes, they can give, but that's not your scope. For your GATE examination, they won't ask that. For in the case of the IES mains, they might ask such type of questions. So don't worry about such a typical questions. This is 2005 and conventional. It is not a main, it is not prelims, it is a 2005 conventional question. And it is a great practice question only. So if you have completed, then I can go for the next one. See, I have given you problems based upon the clay soil mass and based upon the sand. Apart from this, these questions we will be discussing tomorrow. Now, you see this question. This is a ESC 2013. Please observe this question. ESC 2013 question. A single pile of diameter 50 centimeters, which means 0.5 meter, and length is going to be 16 meters, is driven in a clay. Average unconfined compressive strength of 100 kilonewton per meter square. So they have given the unconfined compressive strength, which is going to be 2 times of Cu is going to be 100. Then Cu is going to be 100 by 2, which is going to be 50 kilopascals. See, as they did not mention the average, means a pile tip, as is a uniform deposit. See, you see, they have given some value, that's it, overall value. And then C is equals to, C bar is equals to 50 kilopascals. And mind it, one more thing, neglect the end bearing. If you neglect the end bearing, I don't need to consider this also. When you neglect the end bearing, what is QU? QU is nothing but QB plus QS. If I neglect the end bearing, then QU is equals to QS. Given neglect end bearing. So in the case of the ESC, the type of models are, they won't give you the total question. They will ask you either neglect end bearing or neglect the friction. So in this question, they mentioned clearly. Now you observe QU is equals to the shear mobilization factor also they have given 0.75. You know that QU is nothing but Fs into AS, alpha into C bar into pi into D into L, 0.75 into C bar as a 50 into pi into D value as a 0.5 into what is the L over here, 16. So please find out the ultimate load carrying capacity. Okay, 16 5 is 80. So 16 into 0.5, 8. Okay, 8 into 50. 8 5 is 40. So 400. 400 into 75 means 400 into 0.75, which means 4 into 75. So which is going to be 300. 300 into pi. What is 300 into pi? 3.14. So see, I am not using any. I'm not using any calculator. 300 into 900. 300 into pi. 300 into 3.14. That's going to be more than 900 and less than 1000. So this value is going to be more than 900 and less than 1000. I'm just verifying in the examination what I do. 16 into 0.5, 80, sorry, 16 into 0.5, 8, and 8 into 50, 400, 400 into 0.75, 300 into pi. So this is going to be more than 900 and less than 1000. And if you solve, the answer is going to be C, which is going to be somewhere 300 into 3.15. So 942.47 kilonewtons. So approximately we can take it as 940 kilonewtons. In examination, how to solve, I told you. See, the calculation you have to look at in ESC, they won't give the exact values. They will always ask you approximate values only. Now, this is a homework for you. Here is a previous GATE question, GATE 2008. So this is a homework for you. In this, they have asked skin friction capacity. Again, skin friction capacity means, you know that, QS. Yes. So these things we'll be seeing once we complete the remaining topics. Now, so say for allowable load carrying capacity, QS is equals to QU by factor of safety. Factor of safety is equals to 2.524. That's about the static formula. And next, coming to the second one. Dynamic formula. The second one is going to be dynamic formula. So in the case of the dynamic formula, now you see over here, see this, oh my God, this is going to be QS. This is, you please write it as a Q safe. Some of the persons is asking, sir, you are using QS and I'm sorry. You can write this as a QA is equals to Q safe. In the questions also, please write this as a Q safe. Don't write it as a QS because again you will be. So this is Q safe. Q safe, safe. Yes. So now coming to the dynamic formula. See, this dynamic formula is going to be suitable for cohesionless soils. See, static formula is going to be suitable for all type of soils. It's very static formula, yes. This is suitable for all type of soils. All soils, whereas in the case of the dynamic formula is suitable for cohesionless soil. Why, sir? In this, the dynamic due to dynamic or impact loads, due to dynamic or impacts loads in clays, pore water pressure develops and weakens the soil, comma, remolding happens. And moreover that this is a short duration application. So as it is a short duration application, then the settlements are not going to be actual settlements. So this dynamic formula is suitable for the cohesionless soils. Why, sir? Why not for coastal soils is due to impact. See, this is for the driven piles only. Dynamic formula is for driven piles only, not for any other piles. And I told you, driven piles are used for the, go back. I said over here, the driven piles are going to be used for the granular soils. So now there are some formulas here. Again, engineering. In this, the load capacity of pile or dynamic capacity of pile is equals to weight of hammer multiplied to height of fall, multiplied to height of fall. So if you observe, where is the figure? So this is a pile driving equipment, right? So while they are pile driving, they are going to be drop the hammer. They are going to be drop the hammer. And when they drop the hammer from a certain height, this is the weight of the hammer. And from this certain height to this height, the height of fall. So weight of hammer into height of fall, that's going to be the dynamic capacity of the pile. Okay. Now there are some formulas in the engineering, in this dynamic equation. Engineering news formulae here. He has conducted his analysis on the timber pile. By taking the timber pile, he has done the analysis. Engineering news formulae. So according to this person, the ultimate load is equals to whatever the weight of the hammer into height of fall into efficiency of the hammer by settlement S plus C. Settlement S plus C. Whatever this S is nothing but settlement. I'll tell you later. Just wait. How come a man's name be engineering news? I don't know, yeah. We have to ask him or his mother, but unfortunately there are no more. So, and you know that the safe load or allowable load is known as ultimate by factor of safety. So allowable load is equals to W into H into neta H by F into S plus C. Okay. So this is the equation given by the engineering news, and this is going to be done on the timber piles where W is weight of hammer, H height of fall, so height of fall, and neta H efficiency of hammer. Efficiency of hammer. And what about the remaining things are here? The remaining things are S means settlement for last blow or average settlement of last 5 blows. See, while you are going to construct, now let me draw that. Okay. While you're going to construct a pile on the ground surface, this is the ground surface. Yes. So now I'm just drawing a figure over here. See, this is a pile drying equipment. This is going to be the hammer. Now, on the top of this, we are going to provide a cap. This is known as a dolly or helmet. And you are going to drop it from certain height. This is known as a height of fall. So when you drop this hammer from a certain height, then this pile will start to penetrate into the soil. When the pile is going to be penetrates into the soil mass, now if you observe over here, now along this there is some settlement. What is the settlement for the last blow? Do you think the pile is going to be drive with a single blow? No. The pile is going to be drive for n number of blows. What is the settlement for the last blow is known as a S. And whereas C is constant, represents compression in soil plus dolly plus pile. So there is some compression in the soil plus dolly plus pile. The surrounding soil, you please observe, when you apply this load, the surrounding soil will undergo some compression or not. Whatever the soil below the pile will undergo compression, and this is known as pile. Pile will have some elastic compression. Dolly will have some elastic compression. That is going to be C, and that C is equals to 2.54 for drop hammer, and that C is equals to 0.254 for steam hammer. See, there are different type of hammers. What is mean by drop hammer and what is mean by steam hammer, sir? Drop hammer means free falling. Just you are going to simply drop it. Steam hammer means you are going to control the pressure. So ultimately, this is the engineering news formula equation. And according to engineering news formula, mind it, the factor of safety should be taken as a 6. That is fixed. This factor of safety is going to be 6 according to engineering news formula. The factor of safety is going to be definitely you have to take it as a 6. Why you have to take the 6, sir? Sir, he has done his test on timber pile, sir. So that's the reason why he accounted more factor of safety. So now these are the details in the case of the engineering news formula. C is equals to 0.254 steam hammer. C is equals to 2.54 as a drop hammer. Now let's see. There is one more formula apart from this. There is one more formula. A and B is equals to Heller's formula. So same Heller's formula, but the small difference you can see, observe over here. QA is equals to W into H into neta H into neta B by factor of safety into S plus C by 2. Where in this equation, neta B means efficiency of hammer. Neta B means efficiency of the hammer. And where C is no more constant. The C is going to be not a constant value. You have to take the C value. You have to take the C value as the C represents compression in soil plus dolly plus pile. It's no more, it's not a constant now. See, in the case of the engineering use formula, he took the C is a constant value that represents the compression in dolly and soil and pile. And here in this case, the factor of safety is going to be 2.524. So they will give you the compression values. Don't worry about that. That's about these two equations. One is engineering use formula, other one is going to be Halley's formula. So the same formula, W into H into neta H by factor of safety into S plus C. So if you look over here, that S is equals to 2.524. In the case of the, sorry, it's not yes, sir. Yeah, I'm sorry. Factor of safety is going to be 2.524. So there is no change in the, means the small change is going to be, instead of, in the case of the Halley's formula, wherever the hammer you are going to use, the different type of hammers are there, right? It has a different efficiency. So efficiency of blow. Neta H is going to be efficiency of hammer. Neta B is going to be efficiency of the blow. So that's all with this. Have a look once. Yes, 2.54 centimeters, right? Yeah, I did not represent the centimeters. Sorry. I didn't represent the centimeters. I'm sorry. 2.54 centimeters for drop hammer. 0.254 centimeters for steam hammer. Complete once. These formulas are useful for gate. Yes. How you remember all these formulas? Simple. Practice, practice, practice. I have been delivering the same subject from the past 4.5 years or 4 years. So obviously I can be remembered. But what to do use for the sake of you? You need to practice. That's it. Take a white paper. And whenever you remember the formula, means whenever you memorize the formula, write it continuously. So as even when you wake up from sleep, immediately if I ask you a formula, you have to say. So that's how your preparation should be. That's hard it should be. Which college do you teach? I don't teach any college. I teach only in ACE Engineering Academy. I am a full-time faculty in ACE Engineering Academy. Haven't you written IES because your concept will be thorough? Yes, I did. My focus is different and ESC focus is different. I don't like much regarding to the government jobs. So, I mean, I'm not offending anyone, but I don't like much of the government jobs. So, are you happy with your daily life? Yes, I am so much of happy. I mean, it's been a long time that we have not been discussed some other things. So I'm very happy with this type of work. Actually, I love teaching, and whatever I teach or whatever I study, I always say, and a teaching man only, I always deliver that. So I have a very good interest towards the teaching. So that's the reason why I entered into this field. And moreover, that why can't you join into engineering college, sir? Yes, in engineering college also you can teach, but there you don't get money. But I can get money over here. Okay, now I'll just say something regarding towards. I mean, see, this is that's it for today. This is going to be single files and the dynamic formula. But I want to just say some things regarding to the IITs. So how the culture and how the nature in the IITs would be, and what's my journey in the IIT Hyderabad, and how I ended with the IIT Hyderabad. I'm not saying about the things that I have been through, and I'm not going to focusing also what are the achievements also, but what are the pros and cons in IITs. See, first of all, the point number one that I have learned most in the IIT is it's not about subject. It's not about a subject. I didn't learn any subject in a MTech. Means I do learn, but apart from that, it's about the thinking power. See, the first thing is, everybody, while you are doing in a BTech, I mean, most of the, if you are doing already in MTech, already if you are doing a BTech in your NIT or IIT, I'm not considering them, but I'm saying a normal people, even I have done my BTech in SV University, Tirupati. So as a local college or a regional college, I can say most of the students around me are the friends which are going to be limited to that region. And most of the friends are going to be local friends only. For example, I am Andhra. I mean, I studied in SV University. So most of my friends will be in Telugu or Andhra people only. But the first thing that I learned when I entered into this IIT is there is a multilingual culture. There you are going to see different kind of people. And the different kind of people I say is, I'm defaming over here the caste or something else. The different kind of people means that the people will come from different zones. Somebody will come from north, some northeast, some southwest, from Kerala, and from Jammu and Kashmir also some of the students you will be seeing. And you are going to make sure, and you are going to be show off your emotions or feelings towards each and everyone. And while doing so, you will get to learn how the other persons are going to be take yourself. So some of the people or some of the friends might take it as easy. Some of the people might get offended very easily. So the first thing that you are going to learn once you enter into the IITs is that different way with the different thinkings, and your perspective is going to be changed. So up to the BTech level, your thinking is just like you are just like a frog in a well, and you feel like you are in a world. And you feel like you are a hero in your street as a old hero, but it's not the point. But once you enter out of that scope, and IITs and NITs, there is a large or a huge scope. You are going to see different kinds of mentalities. And moreover, I can say I have been thorough this one also. While you are doing BTech right now also, if you speak with one goal, immediately on the backside of you there will be a lot of rumors. And the same thing with that girl also. If a boy speaks with a girl, there will be a lot of rumors about the girl, and there will be a lot of rumors about the boy also. Yes, and immediately they are going to be taunt you, and it's just like it's being a taboo for you. If you want to talk with a girl whom you like, also it will be a taboo for you because some other friend is going to be offended you, and especially the girl is going to be says that your friends are coming, go 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 like that. So such a narrow-minded thinking would be there in your BTech level. And moreover, you just crossed your intermediate, so you are just still an amateur in thinking levels, and your perspective is going to be very less. Moreover, our environment, local environment confines you. But in the case of the IITs, I'm telling you, your thinking is going to be global, and it's no more confined. And IIT's major point is to evolve and to think on yourself. Most of our colleges, in the BTech colleges, what they do is either they mug up the subject or they won't say any subject. They'll give you the marks directly. And I hope the percentage of the knowledge that you're going to get from the BTech level is very, 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 very less. But in MTech, if you do in IITs, in 2 years of your life, you're going to see a lot of things. And I evolved a lot, and my thinking has been changed a lot during those 2 years of my MTech. So I can see a huge difference in myself while I was doing my BTech and while I was doing my MTech. And that's to the environment that I have been faced over there. There will be no obstacles. There will be no cross fields, and there is no one to stop your thinking. You are allowed to think whatever you want. So there is a free nature. You can cultivate yourself with any person, well, be it girl or a boy. There is no one in means the people. Some people would be there, and I'm not saying entire, but some people would be there. And this is one point. Yes, everybody get that type of rumors. That's going to be common, and that's one point. And number two, in the IITs, the facilities that you are going to see, you have world-class laboratories, and you have a very good playgrounds, and you have very well equipped laboratories, and the facilities they are going to provide is going to be very much. And I love IIT Bombay actually. I have been through, I have been in IIT Bombay. There are a lot of IITs, but even though I have done IIT Hyderabad, but I have been in IIT Bombay for some tech festival. So you see that IIT Bombay, the culture is going to be entirely different over there. You can see full greenery, and you feel like there is no pollution. You are in such a different planet. Once you are in an IIT campus, you feel like such a different planet. I'm not overemphasizing here, but I feel that. But apart from your academics, I'm telling you, once you go into the IITs, your nature towards understanding the life and problems is entirely different. That's really important for you. See, one thing, anybody can solve the problems in the textbook or material. If I deliver some concept to you, and if you understand that concept, then not only me, you can solve the problems in the material. But mind it, in reality, in your real life, the problems are not going to become just like that. Sir, there is a problem, I am going to come. They will come at any point of time, and you should be dare enough, and you should be brave enough to tackle those problems, no matter whatever it is. You should not unhold yourself. You have to shackle all your holdings, and you have to think freely and globally. That should be there. And with respect to time, that is going to become. And so it's better. I have been placed in IIT Hyderabad also. Yes. In which subject you have done MTech, sir? I have done MTech in my geotechnical engineering as my specialization only. So IIT Madras is also very good, but I am saying, my opinion, I am saying, I'm not saying as a global opinion. Yes, it's very good. And the placements, still about your love story. I have too many love stories, so I cannot pick one. Everything is better and best. So a lot of stories are there, but I cannot discuss. Those are personal issues. And that's it. Okay. And my dear, so it's not about, you don't just think that if I go for the MTech, I can go for the higher education, and I can go for I can get better PSUs, or I can get for the better job. See, well, I mean, so by the time I completed my MTech, I got 3 job offers. I got placed in L&T. The package is 55,000 per month in 2014, in 2016. In 2016, so package is 55,000 per month. I got placed in Kalinga University in Orissa, Bhubaneswar, in Bhubaneswar or Calicut, I think so, but Odisha. So Kalinga University, and I got one more university in Hyderabad itself, Vignan or Vasavi. I didn't remember that because it's been a long time. So I got 3 job offers, and their pay was around 60,000 per month. So I denied all those offers the day that I completed my IIT in Hyderabad. On the same day, I joined in the ACE Engineering Academy. June 16th, 2016. That was the day that I completed my MTech in IIT Hyderabad, and immediately I joined in ACE Engineering Academy. And at first I did not get the classes. After 1 month, while I was preparing, I have got the classes. So it's just like it has happened. I don't say it's an achievement, but mind it, there are some situations in your life that comes that you have to stand up on yourself to take your decision. While I came to ACE Engineering Academy, by denying all the jobs, my parents were never a support to me at that point of time. They were denying me, and they were continuously saying, I'm not defaming my parents over here, but I say that my parents didn't accept it at first, because I got the L&T job in BTech also. I did not went for L&T, I went for the IIT Hyderabad. And at the end of the MTech also, I got L&T again. And well, when they got to know that I am not going to L&T again, so they felt so bad, and they felt hurted, and they didn't talk with me for a few days also, a few months. And once they got to know the salary that I got in ACE Engineering Academy, then they start feeling like this is also a good job. So some situations in your life that come, that you have to stand up for yourself. Whatever the decision, no matter whatever the decision you take, see, when you take a decision, the decision at first is not going to be correct or false. You take some decisions. Over some period of time, based upon conditions, it may be correct or it may be false. So just because you took some decision, you don't get regret. But whenever you take a decision, please stand on it. If you want to be loser, you can lose without doing anything. But if you want to learn anything, you just focus, you do something. So in the process, you can learn something that you don't know yet. Yes. So that's what I believe. But apart from this academics, I believe you have to make sure yourself in a global perspective manner. Your thinking matters a lot. Mind it, not only your knowledge, your thinking should be there. That's all matters. If your thinking is going to be pure enough, and if you are able to allow any thoughts, then I'm telling you, you are going to be much more knowledgeable person than anyone who is having 99% academics. So yes, that's all. With this, I'll stop this today, and I'll be taking some doubt clearing session. So whatever you're having a doubt clearing. Okay, now. What is your salary? What is your salary? What is your salary? No, I won't disclose my salary. Okay, fine. Now, I mean, I'm enabling the doubt clearing session. So those who who has doubt clearing session, please raise your hands. Yes, come on, tell me. Okay, fine. Mr. Sachin, please speak out. Mr. Sachin, please speak out.
Hello, sir. Hello,
Yeah.
sir. Can you hear me?
Yeah, I can hear you, Sachin. Please tell me.
Good afternoon, sir. Good afternoon,
Good
sir.
afternoon. Good afternoon.
Sir, can you please check GATE previous year question chapter 14, sir? At pressure theories.
1 minute. Let me save this one.
Okay, sir.
Where is that? Yes. Which one you're saying, please? Gate?
GATE previous year question chapter 14, sir.
Yeah, tell me.
In
Which
that
question?
one mark question number 7, sir.
Actually, that requires some other concept. You don't require that. You please don't look over that one. Okay. See, sometimes
Okay,
this type
sir.
of will be there, but if you go for that, it will be waste of your time.
Okay, sir.
Yeah. Any other?
Sir, another question, sir. It's same one mark question number 9, sir.
Question number?
9.
Yeah.
9, sir.
See, I told you that Ka and Kp depends on
Yes, sir.
effective stresses only. They depends upon
So,
stresses. So if I write that is going to be H into sigma V, that's going to be A is going to be sigma H dash by sigma V dash. Answer is going to be V. I
okay,
told
sir. Okay, sir.
you, when they mention the effective stress, K and K depends upon the effective stress only. Okay?
Okay, sir.
Yeah.
Sir, one more doubt, sir.
Yeah, tell me.
Can you please take chapter 11, sir? Consultation.
Chapter number 11. Which question?
Sir, 2 mark question number 9, sir.
This question, right? I have already discussed that, Ray.
Sir, in
You see,
classroom, sir? Yes.
no, in one of the doubt clearing session only, the average effective overburden pressure on 10 meters thicker clay, saturated clay is going to be, see, they have given sigma naught dash average overburden pressure as 150 kilopascals. Okay. Consolidation
Okay, sir.
on the undisturbed sample. So they have done the consolidation test. From the consolidation test, it got to know that the void ratio decreased from 0.6 to 0.5 by increasing the stress from 100 to 300 kilopascals. So now, if you plot the graph, sigma dash log E, this is going to be the curve, right?
Yes, sir.
Yeah, initially when you test the void ratio is going to be 0.6 and what is the stress at this point? 100. Now, by the time you reach 300 kilopascals, the void ratio is going to be reduced to 0.5. So this is the one. And the question they're asking is the initial void ratio. What is the initial void ratio? What is the initial void ratio? E naught, right?
Yes, sir.
Yes or no? Initial
Yes, sir.
ratio means at the initial overburden pressure. See, first of all, whatever the data they give, from the data, you need to find out the initial void ratio, which means somewhere over here. This is E naught, and what is this value? 150. So what you need to do here is you find out the slope. You know the slope is going to be same, right?
Okay, sir.
What is the slope? Cc is equals to 0.6 minus 0.5 log base 10 300 by 100. You just equate to E naught minus 0.5 by log base 10 150 by 100. Just equate the slopes. This is slope and this slope both are going to be same, right?
Okay, sir. Okay, sir.
Yes, that's it. If you equate that, you can find out the E naught value.
Okay, sir.
Anything?
Sir, one last doubt, sir.
Tell me.
Sir, in that consultation chapter, first question, sir. 1 mark, sir.
Please speak out loudly. Right?
Sir, can you hear me, sir?
Yeah. See, actually, Terzaghi assumed E versus sigma p relation as means this relation is linear. Normally, if it is a normal graph, it's not Terzaghi. If it's a normal analysis, E versus log p is going to be linear. That's no. But Terzaghi,
Okay, sir.
in the case of the Terzaghi's one-dimensional theory,
Yes, sir.
Terzaghi one-dimensional theory, he assumed E versus p itself as a linear because the permeability of the soil he assumed as linear.
Okay, sir.
Okay.
But they have given option B, I think so, sir, answer.
No.
So option A is correct, sir.
Yes.
Okay, sir. Sir,
Okay.
sir
Yeah.
yes, sir. Thank you so much, sir.
Okay.
Okay, sir.
Okay, fine. In chapter number 10, for different R comma values, there is a possibility of seam stress, but Z changes along depth, stress changes now, sir. Sir, when Z changes, R is also going to be changed, sir. So in Kempton's theory, the value of the NC is given as, yes, that's correct only. Can you cross check? No, Mr. Bhuvan, that's correct only. In chapter number 14, previous gate 2 marks, first question, I got answers. So in chapter number 14, two marks, first question, right? Yes. So what's the problem with this? I did not. Point 217. So let's take this question. When an unconfined compressor test is conducted on a cylinder, it fails under axial stress. The axial stress means sigma 1 is equals to 1.2 kg per centimeter square. And the angle alpha f is going to be 50 degrees dimension. So determine the cohesion and angle of intersection. Is it right? I hope this is the question you are asking. Chapter number 14, 2 marks, question 4. Sorry. First question I got answer 0.217. No, means I did not got your question here. So please make sure that question properly. Miss Indu Martha, please, I did not got this. It is chapter number 14 only. Okay. Sorry. 2 marks question. A vertical wall 6 meter high above the water table retains a 20 degrees soil slope. Yes, the retained wall, see, this is a retained a 20 degree soil slope. Whatever, this is nothing but beta. The beta is going to be 20 degree soil slope. Unit weight is going to be 18. Shear strength C0, phi is equals to 40 degrees. Then coefficient of active earth pressure. What is the coefficient of active earth pressure? Cos beta into cos beta minus root of cos square beta minus cos square phi by cos beta plus root of cos square beta plus cos square phi. You substitute this value. If you substitute, the value should be there. The value should be there. So you please solve that one. Previous gate question, chapter number 13, 1 mark, 6th question, sir. Previous gate, chapter number 13, 1 mark, 6th question. See, poorly graded sands will have a lower friction angle than the well-graded sand. The particle size has a no influence on the friction angle of sand. No, the poorly graded sand means the gradation is going to be less. So when the gradation is going to be less, then the angle of interfriction is going to be lower. 1:2 and 3 is false. Meanwhile, some of the students who raise their hands. Mr. Aditya, please raise your hands.
Hello?
Yeah, Aditya, tell me.
Sir, I'm audible, sir?
Yeah, you're audible to me.
Sir, I have doubt in previous ESC question, sir.
Yes.
Page number 88, 41st question.
Previous ESC, page number?
88, sir.
Which question?
41st, sir.
Yeah. See, are
Yes,
you
sir.
sharing this one? Yeah. A retaining wall vertical with a vertical back 6 meters with a slope of 10 degrees for the backfill.
Yes, sir.
So now this is going to be 10 degrees, right, with the backfill.
Yes, sir.
To this, what happens is with the values of KH and KV, the total active earth pressure will be. See, they are mentioning at the base, whatever the, due to this one, at the base, this is going to be the KE. Okay. And this is going to be resolved into two components. The resolved two components are, one is vertical component they have mentioned.
Yes, sir.
Other is a horizontal component they have mentioned. So it's going to be KV and he is going to be KH. So what is KH they have given? 100. Oh, sorry, 760 and KV is going to be 100. See,
Yes, sir.
I'm asking you the active earth pressure in terms of kilonewton per meter, which means they are asking the force. Active
Yes,
force means, so due to vertical stress, then there must be vertical force and there must be some horizontal force. Okay. So if
Yes,
I
sir.
draw the distribution for vertical stress, distribution, they have given, see this is slope now. This
Yes,
is a
sir.
vertical stress distribution. Sorry. In the case of vertical stress, they have given what kV as a 100 kg square, kg per meter square per meter. What is the height? 6 meters. So
Yes,
what
sir.
is the F vertical over here is
300.
vertical stress. The vertical stress acting over here is half into base, 100 into height, 6 square. Half into base into height, 6, right?
300. Yes, sir.
Yes. 300 kilonewton per meter. Similarly, in the case of horizontal, what is horizontal they have given? 760 kg per meter square per meter. So what is FH? Half into 760 into 6. So now you tell me this value. 2, 6, 3 is 2, 3 is 76 into 3. 73 is 210 and 6
480.
228. Yes.
480 plus 1800. 2280. Yes, sir.
Yes, kg. Yes. Now
Yes,
once
sir.
you know this one, then the active force is going to be root of, means you have to take the root, right? Resultant, na?
Yes, sir.
V square plus FH square. So 300 square plus 2280 square. Then the active force would be there. Tell me this value. Is it? 1 minute, give me a minute. Have we done any solution wrong over here?
Half into 763 into 6.
Yes, they're asking in terms of kgs, no, sorry, kilonewtons, right?
Yes, sir.
So if they can ask, see, what is this value?
Kilonewton means 76 and 20 to 28.
Give me a minute. Half into base into height. Okay, that's kg per meter square. That's true. K gamma h square.
Sir, what is the meaning of this kg per meter square per meter, sir?
Per meter means per meter length of the wall.
Okay, okay.
Okay, you please solve this question and tell me the values. So what is the final value of this again?
Yes, sir.
That's kg per meter square. Kg square plus 2280 square root of answer. That's going to be 2299. So, Aditya, I'll check this. There is a small doubt for me also in this question.
Okay, sir.
I'll check this question once.
Yes, sir. Okay, sir. No problem. I'll contact you again.
Yeah. I'll contact you tomorrow because there is some slight problem over here.
Yes, sir.
So I'll check this one. Okay.
Yes, sir. No problem. Thank you, sir.
Yeah. Thank you.
This is the doubt, sir. Yes.
Yeah. Okay. Aditya. Now, yes, there is a formula for this problem. Yes, I'll check that one. Okay. Mr. Kaushik. Stability of slopes, question number 13. I didn't know whether it is gate or IES. Miss Sindhu, speak out. Miss Sindhu, speak out.
Sir, am I audible? Am I audible,
Yeah,
sir?
you're audible to me. You're audible to me. Tell me. Hello. 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 Okay, now next see some of the questions from our students here. Gate number 60, gate number 66, question number 9, page number 66. Page number 66. Yes, what's there in that? So this question using phi u is equals to 0 degrees analysis, the minimum factor of safety against a shear failure for a vertical cut of C. Whenever you see the vertical cut, the maximum depth of vertical cut is going to be HC. So they did not mention any other properties. Did they mention any phi value? C is there, gamma is there, but they did not mention any other factors. Did they mention the angle or something else? No, right? Did they mention the weight? No. Here the factor of safety is with respect to height, just simply. Is a basic function. And what is HC? The H is given as 4 meters, and HC is equals to 4C by gamma root Ka. As a phi is equals to 0 degrees, Ka is equals to 1. So 4 into C value 120 by gamma as 20. So 24 meters. Yes, 24 meters. 26, 6 was 24 meters. So now 24 by 4, the answer is going to be 6. Answer B. Stability of slopes, question number 13, previous year gauge. Question number 13. Stability of slopes, question number 13. See, question number 13, I have done the Mr. Kaushik. I have already done that. You please go through the classroom notes. Next, Mr. Pawan Kalyan, please speak out. Mr. Pawan Kalyan, please speak out.
Hello, sir.
Hello, Pawan, tell me.
Sir, my doubt is regarding previous ESC, sir.
Previous ESC, tell me. Which question?
Page number 91, sir.
Yes.
PDF page number 91, sir.
Yes. I am 91 only, I think so. 91. Okay, fine. 91 now.
Yes, sir.
91 means key sheet ray. Which chapter you're saying? You're saying
Bearing capacity, sir. Sorry, it is PDF, not PDF, sir. That one, the chapter number. Bearing capacity, 9th question, sir.
9th question. This one.
Yes, sir.
Rafts resting on sands can be allowed. Rafts resting on sands can be allowed double of the allowable pressure when the permissible settlement is going to be doubled and length is doubled, depth factor is increased, water table is going to be lowered. Yes. Look, when the water table is going to be raised now, see, I'll tell you one point over here. In the water table, when water table rises in coastal soil, when water table rises from well below to ground level, then the bearing capacity reduced by half or not.
Yes, sir. Yes, sir.
And if the same water table is going to be lowered completely, then the bearing capacity is going to be increases by
50%.
right?
Sir, but the answer is given as option A, sir.
Permissible settlement is doubled.
Yes, sir.
Okay. Let's see this. In the case of the resting of sands, can be allowed double of the allowable pressure. You see, if you remember the ultimate settlement,
Yes, sir.
sorry, not ultimate settlement, immediate settlement is there or not?
Yes,
So,
sir. Yes, sir.
settlement Q is equals to S by,
It's equal to QIB by E into 1 minus mu square.
yeah, S directly proportional to Q, right?
Yes, sir.
So, I think so from here, the allowable pressure is going to be increases when settlement is going to be increases.
Yes, sir.
This, if the allowable pressure is going to be doubled, then the permissible settlement is also going to be doubled. Means when the permissible settlement is doubled, then allowable pressure can be doubled. From this concept, actually the water table also should be lowered. When the water table lowered, also allowable pressure will increase.
Yes, sir.
But they did not mention whether the water table is going to be lowered below the footing or above the footing. Na? So
Okay.
that's some controversy over here.
Okay.
Okay.
Sir, and that 10th question, sir, that angular distribution, what is the thing?
Angular distortion, those are the values, just values. You just go through the previous, some values would be there. You see any textbook, there you can get the values. There is no concept behind that.
Okay, sir. And question number 59, sir. Same chapter.
Question number
59.
Yes. Look, the safe depth of the foundation will be here.
Yes, sir.
If you see a raft foundation of 10 meters wide and 12 meters long. So width of the raft is going to be, width is given as 10 meters and length is going to be 12 meters. In constructed having a shear strength of 20 Newton per meter square, which means clay soil mass. Unit weight of the soil is given as gamma 16 kilonewton per meter cube. Ground surface carries a surcharge of 20. See, this is a footing. Apart from that, there is normally, apart from there is one more surcharge. Okay.
Okay, sir.
Then at this point, what is the surcharge? You can see Q plus gamma D. What
Okay.
you apply 20. Understood?
Yes, sir.
And whatever the soil is there or not.
Yes, sir.
In this depth, there must be some soil mass. So they have given Q plus gamma D.
D.
The value of NC is equals to 5.7, the safe depth of the foundation. D safe. First of all, you find out the critical depth of the foundation. Okay. So I can go with the different procedures and I can get the nearby answers over here. So if I go for the critical height, let's say with this procedure once, force gamma root Ka. So as Ka is equals to 1. 4 into C value. What is C value over here? 12 by gamma
16.
16. So
3
here,
meters.
yes. What is this value? 3 meters, right? This one.
Yes, sir.
If you apply the factor of safety, then factor of safety is equals HC by H.
H.
Which is equals to 3 meters by factor of safety as 1.2. So if you solve this one, then 3 by 1.2, which is going to be
2.5.
so sorry. Yes, 2.5 meters. So this is not there in the option. Is there? So which
No, sir.
is going to be wrong.
Okay.
So first we check this one, and then now what we're going to do is first find out the ultimate bearing capacity.
Okay, sir.
Equation for the ultimate bearing capacity. First of all, I can say this is a clay soil mass. You know that NQ is equals to 1, N gamma is equals to 0, and NC is equals to 5.7. They mentioned clearly.
Yes, sir.
I can remove the width effect directly, and I can write N gamma. So ultimate bearing capacity is equals to, they given as what is the type
Rectangular footing.
of rectangle? 1 plus
1
0
plus 0.3 B by L.
L into CNC plus gamma D normally plus additional surcharge is also there or not?
Yes, sir. Yes, sir.
Into NQ, and NQ is equals to 1.
1.
Now with this we can get to know that 1 plus 0.3 into B by L 10 by 12 into C 12 into NC 5.7 plus gamma 16 into D plus 20. So now what you do is we are going to say against the failure or not. So
Yes, sir.
anything regarding to the failure over here? No. As we don't know the any value of the Q or QU, I can say failure occurs when QU is equals to 0. Means when there is no ultimate bearing capacity of the soil mass, then definitely the failure is going to be happen. Yes. So now if I use this condition, I am using this condition because I don't have any gross pressure or any net pressure. If there is a gross pressure at a failure, I can take Q is equals to QU. Okay. But there is no Q value over here. So first of all,
Sir, can't we consider gross pressure as that surcharge?
no, you cannot consider the gross pressure.
Okay.
If you consider that, that is going to be there. Yes, you can consider that also because I am considering everything over here, right, as a surcharge.
Okay, sir. Okay, sir.
If I consider everything as a surcharge, then I can take C, the same thing plus 20. If you go to the other side, QU minus 20, then it's going to be like a gross pressure only.
Okay, sir.
So now if you substitute 1 plus 0.3 into, please find out this value. Yes, 0.3 into 10. So 3 by 12, 1 by 4, which is going to be 1.2 into 12 into 5.7 plus 20 plus 16 D is equals to 0. Please find out the D value. What is the D value?
Sir, this way we are getting D as negative now, sir.
Yeah, fine, fine. Don't worry.
Then 1.287 meters, sir. Minus 1.287 meters.
Minus 6.59 meters. What is the meaning of minus? The meaning of minus is if you go to the excavation, means if you excavate the soil mass up to 6.59 meters, at this point, the ultimate bearing capacity is equals to 0. Okay.
Okay.
The meaning of this D is excavated by 6.59 meters. But they're asking about the safe depth, Arna.
Yes, sir.
The safe depth is going to be critical depth by factor of safety. So 6.59 by what is the factor of safety? 1.2. Now you
1.2. Yes, sir. Yes, sir. 5.5.
yes, 5.49. Here is going to be 5.5. So this is one way of applying the equation.
Okay, sir.
Okay.
Sir, and one last question, 22, sir.
Yes. It's already 1:30 there. What's that question?
22, sir. 22.
In this chapter only?
Yes, sir.
Yes, tell me. If two foundations, one narrow, another wide, are resting on a bed of a sand carrying the same intensity of load per unit area, then which one is going to be likely to fail early? If two foundations, one narrow and another wide, are going to be resting on a bed of sand, see, one is narrow, other one is going to be wide. Then which one will fail first? So why, sir? Sir, you tell me what is ultimate bearing capacity? Cohesion effect
Plus width effect plus surcharge
plus
effect.
width plus surcharge effect. Yes or no?
Yes, sir.
In the case of the sand, you know that in the case of the sand, you see cohesion effect is going to be 0. Yes or no?
Yes, sir.
You directly proportional to width effect or not?
Yes, sir.
More width, more ultimate bearing capacity. So if the width is going to be more, the ultimate bearing capacity of the footing or soil is going to be more or not? Now you
Yes, sir.
will fail first.
Sir, but the settlement will also be vary now, sir.
The settlement is there, but we are going to discuss about the shear failure, right? Which one is going to be likely to failure first? First of all, we have to check about the ultimate bearing capacity. Settlement would be,
Okay.
but the settlement is going to be up to permissible limits, right?
Okay, sir. Okay, sir.
Yeah.
Okay. Fine, sir. Thank you, sir.
Okay. Now it's already 1:32. Okay, fine. Let's take up. Mr. Harish Gaud, please speak out. Mr. Harish Gaud. Mr. Harish Gaud, please speak out.
I'm audible to you, sir.
Yeah, you're audible. Please tell me.
Sir, chapter number 16, IES 29th question, sir.
So, 16. Means bearing capacity only, right? Which question?
29, sir.
29th question. Yeah, that's good question actually. Yes. So my dear students, you please observe this question. This question is very good question. Actually, this will be done with the mechanics, not with the soils. This will be done with the mechanics. If you are very good at engineering mechanics, then you're gonna solve this one. See, there are two strap footings. A strap footing is going to be provided for the two columns shown in the figure. So there is a strap that you are going to be connected. There is a strap that you are going to be connected over here. And what is the length of the left footing? The length of the left footing. This is the, what is the length of the left footing they are asking. So this is the one footing. So what is this length? Take width of the both footings as a 3.5 meters only. The width is going to be 3.5 meters. So what you are going to do is now from mechanics concept, the vertical forces should be 0. The vertical forces should be 0, which means whatever the vertical forces, summation of the vertical forces R1 plus R2 is equals to 3000 plus 4500, which means 7500 kilonewtons. Now, let's take a moment about A. Take moment about A. See, these concepts will be explained in engineering mechanics. In chapter number 1 itself, you are going to see. So there are the mechanics concepts. Take the moment about A. If you take the moment about A, R2 into this moment 0 and 4500, as this point is going to be passing through A, 0. Then what is the moments, please? So my dear, we have asked this question. I hope you are in inline.
Yes, sir.
Yeah. So now you see whatever this moment, this is going to be anti-clockwise moment, and this is going to be clockwise moment or not?
Yes.
So now 3000 into, what is the distance from here to here? Please tell me.
7.
Is equals to R1 into, you see whatever the distance I mentioned, this distance is going to be 1.2. R1 into 7 minus 1.2. Okay.
Okay, sir.
So find out the R1 value. If you find out the R1 value, 3000 into 7, 21,000 by 7 minus 1.2. So this is going to be 3620.69 kilonewtons. Without calculator, you cannot solve this way.
Sir,
Yes, R1 is there. But what they're asking is length, na?
yes,
So
sir.
given the safe bearing capacity is nothing but whatever the R1 by area of footing. So area of first footing, R1 by B into L. So now what is L? R1 by Q safe into B. 3620.69 by 350 into B value as a 2.5 meters. Find out the R value, L value. By 350 into 2.5, which is going to be, no. Sorry, this is 3.5, no? So which is going to be 2.9
9.5.
meters. The answer is D.
Sir, in 34th question, can you explain, sir? Same chapter. 4.
In this chapter only.
Yes, sir.
What happened? In the plate load test, how is the
So
ultimate
what is the difference?
from the load settlement curve on log graph?
What is the difference between option A and option B, sir?
Log graph means if you provide a log graph, this is see, if the curvature is going to be small, even you provide the log graph, you can get it as a straight line. Sorry, curve. See, in this case, if I provide a curve, can you find it directly?
Yes, sir.
No. So what we are going to do is, we draw initial tangent and we draw final tangent. Wherever they are going to meet, that point is going to be the ultimate load. So answer B.
Actually, answer is given A, sir.
Answer is given A.
Yes, that's why I'm. That's why I'm asking. So.
Okay. Sorry. The point is, this is going to be log one side, right? Yeah.
This is
If you provide log Q and log S, so the curve is going to be looks like a failure point, this value. Yes, if you provide log graph on both sides, and if you provide a normal graph, then this is a curve, na?
Yes.
So in this case, the tangent. So yes, I'm sorry for this.
okay.
Yeah.
Sir, in chapter
This
number
is a
14.
normal graph. This is normal graph. For the
This is
normal
log.
graph, tangents. For the log graph, directly meeting the points of these two. Directly you can find it out. Okay. Yes.
Sir,
Answer
in
is
chapter number 14, 41 questions, sir.
in chapter number
14, sir.
41 question. Yeah, that's what I was looking. We're asking this question, right? That KH and KV, right?
Yes, sir. Yes.
Yeah. So there is a small doubt for me also. I'll check that because of the units I'm looking, means that kilonewton per meter square per meter. I'll be looking that and I'll be letting you know. Okay. That I'll be letting you know. One of our students are charged, but I can get the answer, but I did not have a proper exact reason behind it. I'll be looking that and I'll be discussing tomorrow. Okay.
Okay, thank you, sir.
Yeah. Okay. So for today, it's been like 1:40. It's already like I took 40 minutes. So Asha Shende, previous gate, chapter 14, 2 marks, question number 4 and 8. Chapter number 14, question number 2 marks. 4 and 8th question. Is there any tears? So if you go over here, I'll be for today. Mr. Aditya, please. Those who are in line, please unmute yourself. So Pawan, please unmute. So now, if you see this one, an unsupported excavation is made to a maximum possible depth in clay soil having a gamma D. The anchor net pressure, according to Rankine, C, maximum possible depth means HC. And if you draw the pressure distribution for HC, you know that this is the pressure distribution up to HC. This is ZC and this is ZC. What is this value? 2C root K. So whatever the pressure at base of excavation is 2C root Ka. 2 into C value 100 into root of 1 by 3. Because 530 degrees, Ka is going to be 1 by 3. You please solve the answer, then you can get down the answer. So my dear student, who has asked this question? You please solve this answer. Mr. Kaushik, you please go through the class notes once, so then you can get down that question. In stability of slopes, I have explained the question number 13. Consolidation question number 15, see it's already 145. That's normal question only. You can go through that. You can get it done. That's normal question only. You can get down the answer. You please observe this clearly. Then you can get. So for today's, I'm stopping. Have other session is also there. So that's why I have to stop now. So for today, the West will be seeing remaining things tomorrow.